एक मिनट रुकना कर रहा हूँ।
आयुष तुम जरा 2 मिनट रुक सकते हो। आई गेस स्ट्रीम इज नॉट ऑडिबल। आर वी ऑडिबल नाउ? कोई चैट में बता दो। Hello, are we audible? Hello everybody, welcome Y23s. So I'm here to introduce you to the summer projects which are going to be held in 2024. So these summer projects are designed for you guys so that you can actually get an experience of all the clubs and societies and get to work on complete hands-on projects along with the various coordinators and the various second years and third years who have worked in these clubs and gained those experiences that they can share with you.
For example, maneuvers like inverted flight loops and knife edge. These types of maneuvers can be easily performed using this type of aircraft. In this aircraft, we are planning to build it a wingspan of 1.2 meter and a fuselage 0.96 meter. This is a design of the whole plane which we are making. In this project, you will also learn about AutoCAD like SolidWorks and XFLR5, which is used to analyze the structural analysis of the aircrafts. Other than this, we will mainly focus on fabrication. Fabrication means like building the whole from scratch. Apart from this, we will conduct a 2 weeks workshop in which we will train you how to make a simple aircraft using a foil, and then we will start the project from the 3rd week. First, the project will be start in 3rd week. The project will start by CAD modeling. We will train you how to make CADs, and after the CAD process is done, we will give it to the matrix department for laser cutting. After that laser cutting, we will assemble the whole like the wing part and the stabilizers. complete the midterm evaluation. We will present it in the midterm evaluation, and after the midterm evaluation, we will work on fuselage. Till 6th week, we will focus on completing the fuselage and electronics assembly, and the 7th we will make sure for complete the electronics and testing part. In the 8th week, we will do testing, flying and testing. In this, what Mantis will learn? Mantis will learn the aircraft and aerodynamics in the first 2 weeks of the summer project. After that, we will focus on CAD modeling and then XFLY for flight analysis. The whole plane is made of balsa, which is very good material. It is light and strong material. We are expecting a Mantis of 9 to 10, and the timeline for the whole project is 8 weeks, in which we will take 9 hours per week commitment. All you need is N2, and we will train you from scratch.
अभी तो शायद मैं कुछ बोल नहीं रहा। अच्छा, वॉल्यूम तो एक्चुअली मैं कंट्रोल नहीं कर सकता इसकी, मतलब जितनी मैक्स हो सकती है मैंने बढ़ा दिया है। उसके बाद वो मतलब सोर्स पे डिपेंड कर रहा है। अच्छा ठीक है, मैं एक बार वापस चेक करता हूँ। हाँ हाँ हेलो। हाँ दिवांश बोल।
Rakshita, I guess you can begin.
OBS से चला रहा हूँ मैं तो। हाँ वही तो, OBS से ही चला रहा हूँ मैं। क्यों दिक्कत आ रही वो समझ नहीं आ रहा था मुझे क्या हो रहा है। हाँ हाँ मतलब तब भी ऐसे ही आ रहा था, थोड़ा तो कम आ रहा है आवाज। यूट्यूब पे मैं यहाँ से तो ट्राई कर रहा हूँ जितनी हो सके उतनी बढ़ाने की।
Good afternoon. This is our second project from Aero Modeling Club, Magnus plane. So this is mentored by me, Harshita, and my colleague Pranay. Now, how does the Magnus effect work? Pranay.
मैं वॉल्यूम का एक बार वापस कुछ देखता हूँ, 5 मिनट। Why the fuck?
Harshita, I guess you can continue.
Hello everyone, this is Pranay Chaudhary or the Magnus effect Sampanewalo. So basically what happens, because a cylindrical body or spherical body rolls in airflow, so it speeds up the upper air and air on the opposite side slow down. So basically it creates a pressure difference between the two sides, and swing ball in cricket and even banana kick of football. So basically we are making a plane using Magnus effect. So we will be also learning the applications of Magnus effect and all. Now over to Harshita for further details.
So the further details and the physics about how the plane will fly, this will be given in the intro lectures in the project itself. Now, what you guys will learn in the project So we'll learn about the Magnus effect and its applications in the real world, and also how we'll use this Magnus effect to generate the lift in our plane. And we'll be using XLFR5 software for our flight analysis of our plane. And you'll be learning different kinds of fabrication methods, which will involve foams, balsa wood, and also you'll be learning stable flying for trainer planes. Now, there is no prereq for this, and number of mentees will be 10 to 12. Next.
Hello everyone. So the second project will be Tricopter. This will be offered by Kirtana and me, Sujit. And so this is not a conventional type of like multi-drone. It will create lift with 3 motors, and so here you can see the complications that we have to balance the torque. So in the quadcopter or the hexacopter, we have even numbers of motors, so we can balance the torque. But in this configuration, we have to balance the torque and the angular momentum with the 3 motors. So it is going to be difficult, and how we will be doing that, we will see during the project, and it will be fun. Next. So this will be the basic dimension of this quadcopter, and the flight controller we will be using is Pixoc, and some basic motors and ESCs. So here is the basic physics of like how we will be doing it during the project. So like here you can see that rotor 1 and rotor 2 is in upward direction, and to balance the torque of those motors, we tilt the motor 3 in certain axis, so that we can balance the torque created by motor 1 and motor 2. Next. Okay, so this will be the basic design for our tricopter. Okay, and the this calibration will be done on this what is called beta flight, and next, and then we will fly. Here is a short clip of that. Actually, this was not the tricopter. This was a basic plane. So for the like, we had a video of this tricopter, but like I don't know, but like we will see see it that in our project. So going to the next project.
So hello everyone, am I audible? Okay, so this is the 4th project in our group. This is the flying wing. Next. So as you can see, this is basically a different kind of plane, and most of the conventional plane that you see in everyday life. Next. These are the 3 mentors who are going to mentor this project. The first one is me, myself, and second is Arusi, and the third one is Akanksha. Both of them are ex-Sekis of the club. Next. So as you can see, this is a normal RC plane that you see in everyday life, and now we are going to see what exactly is a flying wing then. Next. So from this you can see that there are majorly three important parts in an aircraft. The first one is wing, second is the motor, and third is the control surfaces, basically the vertical and the horizontal stabilizer, which are the rudder and the elevator respectively. Next. Now what we do in a flying wing is that we bring the rudder from the back of the aircraft to the side of the wings. Like as you can see that there is a left and a right rudder, both are on the both ends of the wing. And we are taking the motor from the front of the aircraft to just behind the wings. And there is nothing else in the plane. Like we have removed the fuselage, we have brought the control surfaces in the front and the motor in the middle of the wing. So this is what exactly is a flying wing. It is a smaller kind of aircraft which does not have a fuselage, or it does not have a central body. Like, okay, next. So how is it different from a RC plane? So basically it is lightweight, like obviously. It has very high maneuverability because it has low moment of inertia about all its axis except for the roll axis, that is the wing axis. The third point is it has a smaller cross-section area, so it will create low drag, and thus it will also require low power. So you can fly it with a smaller battery, and it can carry a higher payload. Okay, next. So what were we expecting from you? So we are expecting 8 to 10 mentees, but we can increase if there is a high number of requirements. There is no prerequisites, only enthusiasm required, and the time commitment is also very chill. You just have to commit 6 to 8 hours per week. Some part might also be online. I will explain that later. Next. So these are the dimensions. You don't have to worry about this right now. Next. So what you will learn. The first thing that you are going to learn is the trainer plane fabrication. This will be conducted in the first 2 weeks of the workshop. Next. Second is obviously making the working principle and fabrication of the flying wing. You will also learn the physics behind how this thing works. Next. We are also going to create a CAD design for our flying wing. You are also going to create a CAD design for the trainer plane that you are going to make. You are also going to learn the basics of CAD in this workshop. Next. After that, we are going to analyze the CAD design that you had made, both for the flying wings and the trainer plane design. You are also going to learn the basics of XFLR5 software in this workshop. This will be conducted till your midterm evaluations. Okay, next. And so, okay, you can't see the video right now. We will post it at the end of all the slides. Okay, next. Next. Okay, you can't even see this. So this is the basic timeline of how we are going to proceed. The first and second week are going to be the trainer plane fabrication. From the third week, we will start discussing the intro lectures and the XFLR5 software. In the fourth week, we will discuss CAD and XFLR5. We are also going to create the CAD model of your project and do the analysis using XFLR5 in that period. After this, you will have your midterm evaluations. Then from the fifth week, we will start the fabrication of the main project. In the sixth week, we will do the electronics. And finally, we will do the flying test of all this. If there is any changes that is required, we will do that in the seventh and eighth week. And after that, we will have your end-term evaluations. Okay, thank you. Okay, next.
मतलब एक्सेप्ट कर लिया मैंने एडमिट कर लिया और स्ट्रीम ऑडियो तो मतलब नहीं हो पा रहा है चेंज। हाँ नहीं, मेरे को कुछ दिखा नहीं रहा किसी की भी।
Integrator, I guess you can implement that one.
Hello everyone, I'm audible. Am I audible?
Yes, Apurva, you can begin.
So next slide, this is the project UAV integrator. So this is our team, me, Apurva and Manish. Next, what is UAV integrator? We are all like what this term means basically. So next. So this is the UAV integrator. So you can see this. So fuselage and the wingspan is larger than twice the size of the fuselage, and there are like 6 servos used in this, and there are 2 rudders and 2 horizontal stabilizers you can see, and the propeller is motor is on the back side of the plane. So next. So UAV is basically unmanned aerial vehicle and integrator, which means role of bringing together diverse elements like all the systems we have to use in the UAV. So it integrates together, and this is basically called as UAV integrator. Next. So this is the flying of the UAV integrator. Next, please. So what we all learn in this, like aerodynamics, electronics, and the control systems of the aircraft. First, this is the basic knowledge we have to gain from the project, and the followed by the trainer fabrication, which includes assembly of all the electronics and the components of aircrafts. And third, manufacturing processes like soldering and drilling, which we learned from Aero Modeling Club only. And like softwares like AutoCAD, XFLR5, and along with the flight simulator which we use in our club. And fifth, which is UAV integrator fabrication, developing practical skills in prototyping and problem solving. And last, which is the most important thing, flying. Next.
Hello.
So timeline will be, first week will be given the introductory lectures. In the second week, they will be divided into 2 groups for trainer fabrication, and simulator practice will also be conducted. In the third week, flying sessions will be conducted for the practice, like for the trainer flying. Next. Discussion of the project structures and the details, which include which is the main project, that is UAV integrator. So we'll be discussing the fabrication of the project and all the electronics, and assigning in the fifth, assigning the tasks and the fabrication, and 6th week completing the fabrication. Next. In the last 2 weeks, we'll be doing the all the leftover of the project, like and doing some changes in the projects which will be required. So adjusting all the things. Next. This is the flying video of a trainer.
be skipping this part, and all the project need from you is time and enthu. Basically, your enthu and also the time is also the requirement of the project. And we expect 8 to 10 mentees in the project, and the time commitment is also 8 to 10 hours. So we welcome you all. Thank you.
Hello, Bachcho. So this will be our next project, which is this name is Stratolaunch. And these are the mentors. The mentors are Prabal Pratap Singh, Junaid Ahmed, and Lekhansh. So in this project, we will be manufacturing fabricating a plane which has two fuselages instead of one. So this is a new idea which we are planning to implement through this project. And so since it has two fuselages, it will contain basically two of all the things which we generally use for one single fuselage. So there are some electronic components which are usually used in this hobby aero modeling. So in this project, we would be utilizing two of the for our plan. So the specifications include a bi-fuselage plane with double thrusters, and the body would be made out of balsa wood. The balsa wood is an excellent material due to its lightweight and high strength. And it would also contain a landing gear, double landing gears actually, for the fuselage. And yeah, this is basically the basic outline of the model. So, what you will be learning in this as a part of this project, as a mentee of this project, is firstly we will teach you the basic aerodynamics of how the basic aerodynamics associated with how a plane flies, and you'll be able to visualize what would happen when an aircraft would be flying actually. And we'll also teach you how to fabricate simple GAN plane. Obviously, we won't start directly with a project. Firstly, we will teach you a basic small model, and then we would be focusing on the main project. So, since we will be teaching you on a small aircraft, you will be able to understand and take your own time to understand what's going on and how to manufacture and how to fabricate. And obviously, once you have fabricated a plane, the best part would be the flying. So we would also teach you how to fly this aircraft. Firstly, we teach you the flying on simulator, and once you have excelled in the simulator, we will be giving you the opportunity to fly the actual plane which we will be manufacturing. And apart from this, we would also teach you the electronics which is associated with the airplane, which the basic elements include a motor and a speed controller for the motor, and there is another thing called the servo motor, which
पंखा रहने दो क्योंकि पहले ही ऑडियो ब्रेक कर रहा है.
And of course, there is a transmitter and the receiver, so we will be teaching you how to connect those and how each component works. And also, of course, we will also teach you the CAD software, like for example, student projection. And this is also quite useful, not even for this project, it is also quite useful in the future.
So, hello everyone, I'm the second mentor of this project, Prabal. So, this will be a rough timeline. So on the first week, we'll introduce you to the club activities and everything and how does it all work. On week 2, we'll start with the trainer fabrication. So what is a trainer plane? Trainer plane is like a less complicated plane which will be making, like we are making a Barca plane in the project. So trainer plane is made by foam and like styrofoam wing, and it is cut using hot wire. So it will be easy to test it because it costs less, so we can also fly it easily. So we are preparing ourselves for the main project by making a trainer plane. On the third week, we'll start with the flying sessions. So during the first and second week, we'll divide you into 2 groups. So alternatively, one on the first week, like the first group will be making the trainer plane, and the other group will be learning how to fly a plane in the simulator. So we have a simulator in the club itself. So on the 4th week, we'll tell you the basic overview of the project and the fabrication will start. And we are also accepting some inputs from your side. So if you want some changes or if you want to suggest something about the project, you can reach out to us. On the week 5, we'll start making the fuselages. So as you can see that, as you saw in the last slide, that there are 2 fuselages in the project. So we'll divide into 2 groups, and we'll start with the making of the fuselage. On the week 6, this is actually changed. We'll be making the skeletal of the wing. So this is not the wing which we'll be making. On the week 7, we'll have installment of landing gears and electronics. And on the week 8, calibration of electronics and work on aesthetics. So like we'll also have to make the plane good looking, and we'll test the electronics, and then we'll go for flying. So we expect you to devote 10 to 11 hours per week, and obviously the prereq is just ending. Thank you so much.
Hello. Am I audible? I hope I'm audible.
Yes, I hear audible.
Okay. So this is yet another summer project offered by Aero Modeling Club. Okay, so this project is mentored by me. I'm an ex-coordinator of the club, and Bharat Kumar Jahangir, who is the current coordinator of the club. Okay, so let's start with the details of the project. Okay, so this is going to be fun. Okay, so this particular project is about, like, as the name suggests, thrust vectoring. So in this project, our main focus is to fly our plane using, by redirecting the thrust itself, not using control surfaces. So in conventional planes, what we do is, we have some flaps, we have wings, and we bend them in order to create such an airflow that it redirects plane in certain way. But in this one, we are going to redirect thrust itself, which is very new concept. I mean, not very new particularly, but for a hobby grade craft, it is very new. Okay. Again, this project have one speciality that, okay, I will not bore any one of you with modeling and simulation and all those stuff. This is going to be ground level work. You will handle things, you will handle tools and all of those things. You will have some ground level experience for this project. Okay. So, basic idea is when you see a fighter jet, let's say, it is capable of doing some special maneuvers that a normal, conventional or cargo plane is not able to do. That is mostly because of how we handle its control surfaces, yes. So, because it has thrust capability, it is able to perform some particular maneuvers that normal plane can't. Let's say stall turn, or let's say cobra maneuver, which is very popular. Okay, so as it is written in the slides itself, it will be able to do flight maneuvers and stunts. Okay, so most of the body will be fabricated with foam sheets, and the thrust vectoring module itself will be 3D printed. And once we start the project, we'll discuss rest of the details. Now we can come to the next slide. Okay, so this is the timeline for the project. Okay, as you can see, a common trend among all the aero modeling projects, we have like first 1 and 2 week for trainer plane fabrication, which is very crucial for like initiating a beginner's understanding in your like mind that how a basic plane works and how a basic plane is fabricated by hobby grade artists like us. So that is a very crucial part for like initiating an enthusiasm and initiating some level of intuition in your mind to begin the main project. Okay, so again we will spend first 2 weeks for trainer plane fabrication and flying. As you might have seen in other projects, we have also shown you some flying videos and stuff like that. From third week we will start working on our main project. Third week will like mostly go with like fabrication of fuselage and wing and all. From fifth week, which is probably after midterm, we will start working on thrust vectoring module. Before that, we will like fabricate entire plane that is capable of flying without the thrust vectoring. Thrust vectoring is an addition to the main project. Okay. So after midterm, we will start working on thrust vectoring module and then set up everything. And by week 7, we will finish our project hopefully. And of course, last 2 weeks are kept for debugging and like curing if there is a flaw in our like procedure of making the project. So we can continue. Next slide. Okay, so I'm expecting like 10 to 12 mentees in this project because obviously this is a slightly complicated project. We can't like handle 20-30 people in this one alone. Everyone will not get like a personal hands-on experience. So I like 10 to 12 mentees is perfect for this project. Skill set expected, you don't have to worry about any of those. Like first 2 weeks are just dedicated to teach you what you require. Okay, so even if you are coming with nothing, that is fine. That will be fine. Actually, that is expected. You are coming here to learn. Okay. And also time requirement is 14 to 15 hours per week. That is like, okay, that is the basic. Can't expect less than that. Okay. So any more slide left? I think that's it. Thank you. Okay, trust me, this one is going to be fun. Thank you. You can continue our next project.
हेलो किसको अभी तक कोई आया नहीं है ठीक
Great to have a modeling club. Those look like really interesting projects. Moving on to Astronomy Club.
Hello. Aero Modeling Club has made a small clip for the every participant. I would like to show them the video.
Sure.
that's all from our side. Thank you everyone. We will hope you will join in large numbers.
Thank you, Modeling Club. New member Astronomy Club. I guess Ayush Bukhari could begin.
Hello.
Yes, Ayush, you're audible.
Yeah. So, hello everybody. Myself, Ayush Bokad, and I am coordinator of Astronomy Club. So, this year we Astronomy Club are presenting 4 summer projects. First one is Exostellar Nexus, which is bridging interstellar worlds. Second one is L5 Horizon, that is we will build a spaceship at Lagrange point 5. Third one is Red Planet Odyssey, which is basically Martian land analysis. And fourth one is Cosmic Quest. So, moving towards first project, Exostellar Nexus, bridging interstellar worlds. So, project mentors are me, Ayush Bokad, Sanskar Srivastava, and Abhivardhan. So, let me give you a short glimpse of what this project is about. So, here we try to blend the astronomy with the real world ML application of it. So, basically, we will be working with constellations and we will generate a model which will tell us about any number of constellations and their names present in any image of night sky. And secondly, we will generate an algorithm which will tell us about habitability status of any exoplanet, whether it is in Goldilocks zone or not. So moving further. So these are majorly 2 objectives of the project. First one is Heavenly Horizons, mapping the cosmos. We'll learn about theoretical astronomy, telescope handling, astrophotography in all this to achieve our objective 1 for the project. Second one is Blue Heaven detection, interstellar quest for survival. This is objective 2, which will basically deal with all the exoplanet stuff. So this is a short project roadmap. So in first week we will do all the intro thing, celestial coordinate system, telescope handling, classification of astronomical objects. Week 2 we will move further detail in theoretical astronomy, astrophysics and astrophotography. Third week will be something about practical part, which we will have a Tooth observatory, and we will start the ML part here with intro to NumPy, Seaborn and Pandas. Week 4 we will have object detection, image processing and generating training dataset for our objective 1 of constellation detection. In week 5 we will learn intro to Astropy, R cascade, and we will complete our objective 1 of deploying ML model for constellation detection in week 5. So moving further, week 6 we will learn about transit photometry and learning the similarities which tell us about the atmospheric composition about any exoplanet based on its transit data. In week 7 we will get those transit datasets for various exoplanets. We will compute atmospheric compositions and classification theory we will learn in ML, and we will generate the algorithm of that simulation of that simulator by our own using ML. And in the final week, week 8, we will learn about Optimus for habitability, what mainly is Goldilocks zone, and we will deploy our ML model for detecting habitable exoplanets, which will be future human endeavors. So, level of the project is medium. Prerequisite is none other than Enthu. We just want your commitment to work. Weekly commitment, it will be not more than 12 to 15 hours. We are expecting like 15 mentees because ML related project, and we have tried to blend astronomy with ML part. So finally we will have 2 deliverables. First one is we will have ML model telling names of constellation in any image of night sky. So basically we will work with the constellations in northern hemisphere that are basically 36 constellations overall the year, and presently we will have over it 10 to 12 constellations which are visible in May and June. Second deliverable which we have is we will have ML algorithm telling habitability status of exoplanet based on its transit data. Later learning outcomes, theoretical astronomy knowledge, astronomical tool modeling, machine learning application, object detection, R cascade, image processing and classification theory. So this was all about first project. So hope to see you in large numbers. Bon voyage. So nextly Soil will continue.
Kunal, I would request you to turn on your camera.
Hi everyone. Am I audible?
Yes, so you're audible. Just turn on the camera.
Hi everyone, my name is Sohail and I am the coordinator of the Astronomy Club. And so this is the project which I am offering with other two guys, who are Atif and Prabhanshu. So the project is basically L5 Horizon, crafting the future of space habitats. Basically in this project we are going to design a spaceship at the L5. So first let us know what are Lagrange points. Some of you will know and some who don't know, let me tell you. Basically the Earth's sun system has total 5 Lagrange points in them, where the gravitational pull of the sun and the Earth basically balances each other, and if we put any spacecraft there, it will not require any fuel consumption, basically very less fuel consumption to be remain there. For example, currently James Webb is at L2 and Aditya L1, which was launched last year by the India, is currently at L1. These are known as the parking spots of the space. So basically there is nothing right now at the L5. So let's fill the L5 through this project. So basically what we are going to do in this project, we are going to design a spacecraft that will support future space missions at the L5. Okay, so basically through this project we will be answering the following questions also. That what should be the shape of the spacecraft? Should it be toroidal or spherical or any other? Or how we will protect our spacecraft from asteroids, because asteroids will be there at L5 too. How energy will be produced for this spacecraft, how communication will be working with the Earth, and many more. Also, we'll be understand the working of the current space station and learning different fields like astrophysics, astrobiology, astrochemistry. Because in the ISS, you know that humans live there. Humans go there for the projects and then come to the Earth. Then ships go there all the year. So basically, it is necessary for the humans to live there. So we will also be learning some concepts of astrobiology, astrochemistry, astrophysics. So basically, finally, in the project, we will be making a CAD or a Fusion 360 model with the 3D dream model of the spacecraft. Basically, goals of the project are very clear. First, we will be making a 3D model of the spacecraft that will support future space missions at L5 using styrofoam shapes. Second is the CAD model. We will be making a detailed CAD model of the spacecraft using Fusion 360 or AutoCAD. And we will also, the final most important, we will make and try to publish a final report that if in the future the humans go to the L5 for the space missions, then what would be the requirements they will be needing? Okay, so what will the requirements should be there so that they can fulfill, so that they can basically support the future space missions at the L5. Okay, so these three are the goals of the project. If we talk about the prerequisites, it's all about your N2, and don't worry if you don't know the fusion or the CAD, we will teach you. Time requirement is basically 12 to 15 hours a week, but maybe less, maybe only less than 12 or 15 hours a week, not more than that. Project duration is 7 weeks, and some extra perks if I tell you about this project is that all the mentees will be given some basic telescope handling training, star hopping, astrophotography training throughout the period of the project. I will be giving all this training to all of my mentees. So I welcome you all to this project. So let your imagination dance to infinity and save the human civilization by providing a spacecraft community. Basically, this project will let you to think to the infinity and provide your imaginable, basically what you think, what you can most think about the spacecraft. But this should be in the spacecraft, or this should be in the spacecraft. We will also review through the professor that what we have made is optimal or not. And all the meetings will be there in the Astronomy Club room, which is at the top of the OIT, and you will all get the star hopping and the basic telescope training throughout the tenure. And you will be there in the planetarium, which is at the OIT rooftop all the time throughout the project. And you will just enjoy the vibes of the Astronomy Club, which is one of the oldest club of the IT campus. So hope to see you in large numbers. So now handling to the Astit.
Hello everyone. This is my project. I am presenting it with two other mentors, Paritosh Jain and Swisha Singh. So the basically this project is all about astrobiology and one of its applications, that is basically we are going to design a simulation of Mars environment in the laboratory. So basically we will start this project with some of the basic knowledge of astrobiology and planetary habitability that is you need to know before working on this project. So basically this page contains an introduction of astrobiology and planetary habitability, and we will provide further resources that will help you in learning understanding these topics. And we have also planned to show you some of the documentaries related to these topics. Then this is the basic overview of the project. We will start with the mainly why we need to do this project. We will start with how can we explore life beyond Earth, and what are the factors that affect life on a particular planet. Then how do the species on a particular planet evolve and adapt to their surroundings, and what are their adaptation techniques. So basically then after acquiring all these knowledge, we will move towards the main part of this project, that is designing the Mars simulated environment in an enclosed chamber, which will mostly be in a tank mainly of an aquarium size. So we'll start with the designing the environment, and we'll be guided by one of the professors in our college only. He's a professor in the Busway Labs. So we'll work in his guidance, and all the needed materials like the microbial cultures and everything will be provided by him only. We'll simply start building it and monitor it to extract different information from the simulation. So basically the goals of these projects include firstly to teach the mentees about astrobiology and planetary habitability, then basically designing the simulation of Mars and extracting the different information from the Mars environment. So basically this project will increase your knowledge on in a great sense, because if you know about this project, the different conditions of Mars environment and how the microbial cultures adapt themselves or survive to these conditions, it will be a great knowledge for you for everyone, because everyone plans, as we know, everyone is planning to colonize Mars in the future. So this project will serve as a great knowledge to the whole scientific community, and if we are able to, we're also planning to publish a research paper regarding this project. So yeah, it will be a great opportunity for all of you, and the prerequisites are none. Basically we'll teach you everything that is needed to work on this project, and basically it's a completely new kind of project, so we do not expect everyone to know about astrobiology. So the prerequisites are none. If you are interested, then you can learn about astrobiology and different things, planetary habitability and all. But all in all, this is a extremely interesting topic and interesting project to work upon. The time requirement will be around 12 to 15 hours a week, and the project duration will be up to 7 weeks. So yeah, this was the Mars environment project. So yeah, it will be a great project, and I welcome you all. Now, thank you. This was all. I'll hand over to Tanish.
Hi everyone, I hope I'm audible. So, hi everyone, I am a mentor of the project Cosmic Quest, along with Ayush Baghel and Tanish Singla. So, what is this Cosmic Quest? First, let us look at these two pictures. What do you see in the first picture? So, there are 5 light sources. The middle source which is present is a galaxy. Now, Now, if I ask you how many of these sources are stars, one might reply that there are 4 stars. But the answer is in fact it's only 1 star. So how does this happen? What is the phenomenon? The answer is gravitational lensing. So a single star, due to the bending of light due to the galaxy, it appears as 4 stars. Sometimes it appears as a complete disk. So what we are going to do in this project is learn about it. We will look at the cases which are found by different telescopes like Hubble, JWST. We will try to find ourselves some cases which are still not found of the gravitational lensing using AI, machine learning, using CNNs, etc. So this is the first part of the project. The second part of the project focuses on Uranus, no pun intended. So what compounds are present in the atmosphere of Uranus? So wouldn't it be great to look at it for yourself and find out? Because that's exactly what we'll be doing. We'll take pictures of Uranus using telescopes and cameras, and we'll take the spectrographs of Uranus using lens grating, and then find the composition that is present on Uranus. So that's the second part of the project. Coming to an overview of the project, the first part will be a theory. So all the deep space theory lovers, you are in for a treat. We'll be discussing relativity, dark matter, gravitational lensing, and all the really exciting stuff that's present. We'll write a project report, a paper, let's say, regarding all the things that we learn in this. We'll also do machine learning. First, the basics of machine learning will be taught to you, and then we'll use the DESI dataset to find the gravitational lensing cases in those photos that are taken by telescopes using this machine learning. We'll also do spectroscopy, so we'll capture the photos of stars and planets, say Uranus, and we'll find their composition, their redshift, etc. For which we obviously require telescope handling and astrophotography, which will also be taught to you in the project. Coming to the timeline, a brief timeline. The first 2 weeks focus on the theory, all the theory that you require, and a basic Python. Then the third week will be a lot of fun because that's where we enter the astrophotography part. We'll go to the observatory and we'll take pictures. Then weeks 4 and 5 deal with the machine learning part. You will be taught convolutional neural networks and then ResNet, and then we use that ResNet to identify the lens candidates in the dataset that is provided by the Hubble and JWST telescopes. Then in week 6 and 7, we'll move our lenses to the Uranus and we'll capture the photos of it, and we'll find the spectrograph and look at the composition of Uranus. If time permits, we'll also detect the redshift of one of the quasars, a quasar known as QSO 3C273. That will be the end-term deliverable of the project. So the prerequisites is just N2. If you are interested in astrophysics, in the theory part, deep space, machine learning, or the spectroscope and all this stuff, it's one of the most really interesting projects that you can take. The weekly hours are 7 to 9 hours per week, and the project duration is 7 weeks. So prepare your Uranus for some probing. So these are the 4 projects of the Astronomy Club. If you have any questions, you can contact any of the coordinators. Their numbers and email IDs are present here. You can also join our Discord server for any further updates. Thank you. This is the Astronomy Club. Cosmos is within us.
Great presentation, Astronomy Club. I guess now we move on to Descon Society. So, Descon. Thanks over to you, Kavi.
So, firstly, a very good afternoon to everyone. Greetings from Descon Society. My name is Roshan Patil, one of the leaders at Descon. And this year, we have come up with 3 summer projects. The first one being Hot Wheels and 3D game with Fusion 360. Second is creating virtual reality world using Blender. And third is Encryption and Decryption using MATLAB. So let's see them in detail. So, Arya, over to you.
Thank you, Roshan. Ladies and gentlemen, I, Arya Surate, am thrilled to introduce an exciting project, Hot Wheels in 3D game with Fusion 360. In this adventure, participants will dive into Fusion 360 to create sleek 3D car models and then bring them to life Unity for an exhilarating racing game. But we're not stopping here. We're also bringing these designs into a physical realm through 3D printing. Let us now look at the skills learned. Through Fusion 360, Unity and 3D printing, participants will acquire skills in computer-aided design CAD by creating detailed car models. Along with that, they will also learn to import and animate them with Unity. But not just that, they will use 3D printing as well, and they will learn additive manufacturing. Moving on. This 8-week project starting May 6th will require 6 to 7 hours per week. We're looking for 10 to 15 enthusiastic individuals ready to dive into this creative journey. The only prereq is your enthusiasm. The mentors for this project will be me, Arya Sarate. Yes, will be me, Arya Sarate, Kavi, and Sparsh Gupta. Our details are also given below. We eagerly look forward to your presence and participation in this exciting endeavor. Thank you.
So, hi everyone. After the Fusion project, we are also offering a project which is basically based on Blender, in which we aim to create a virtual reality world using Blender. So, this immersive project guides you through the building techniques which you have to go through to create your own 3D software. So in this, the skills learned would be, firstly we'll be giving you basics of Blender, and we'll teach you 3D modeling basics, and we'll move on to advanced modeling techniques, and then we'll teach you how to utilize modifiers for building complex models. After that, we'll move on to the texturing part, in which you'll be taught about how to apply and manipulate textures on 3D models to add realism and depth. After that, the final part of the project would be teaching you lighting and rendering, in which you'll learn to transform the 3D models into final images and then add up some manipulations to create a final VR platform. The logistics of the projects are the duration of the project would be around 8 weeks. We expect you a 7 or 8 hours commitment, weekly commitment. We are expecting 10 to 15 mentors, and we don't expect any prerequisites from you. Just the only prerequisite is enthusiasm for learning. And the mentors are Akash Rajwar, Karthik Diwan, and Tushar Verma. And their details are mentioned below. If you have any further doubts about the project, you can directly contact them. And we are hoping to see you in large numbers.
So next we have encryption and decryption using MATLAB. So first I'll give you a brief overview of the project. So at first, we'll introduce you with MATLAB. MATLAB is a professional programming tool. We'll also equip you with numerous encryption-decryption techniques and the codes related to them. So the skills that we'll teach you are, next slide please. So first, we'll teach you MATLAB. We'll start from the very scratch, so no prior coding knowledge is required from you guys. Then we'll dive deeper into MATLAB, telling you advanced functionalities of MATLAB. Secondly, we'll teach you numerous encryption and decryption approaches, techniques, which will also include some plot-based techniques, which are very interesting. And thirdly, at the end of the project, you will be so equipped with MATLAB and encryption-decryption techniques that you can devise your own way to create an approach. Means you would have created your own code language. Next slide. So the logistics are simple. It will be a 7 weeks long project. 6 to 7 hours are required from you guys. We'll be taking around 10 to 15 mentees in this project, and there is no prereq required. Only basic knowledge of ESC 111 is appreciable but not mandatory. So the only prereq is year N2. So the mentors for this project are first me, Roshan Padil, and along with me will be Ankit. So these are contact details along with your names in the PPT. So if you have any doubt, you can drop a message. And that is it from me and Descon. We'll see you in our first session. Thank you.
Thank you, Roshan. Moving on to Electronics Club.
Hi everyone, we are Electronics Club and we'll be introducing our summer projects. So we'll be offering 6 summer projects. Let's start with the first one. So the first one is air drums. Imagine having drumsticks that can sense your movement and play drum sounds without actually needing a drum set. So that's what air drums is about. We are working on making drumsticks that are smart and portable. So how are we going to do it? We are going to create a PCB which we'll attach to the drumsticks. Inside the PCB, there'll be an IMU, which is an inertial measurement unit, which is a smart sensor. It can measure how the drumstick moves in 3 different ways. Where they are, how they're rotating, and how fast they're moving. So when you hit the air with these drumsticks, the IMU will detect the movement, but then how do you turn that movement into drum sounds? So that's where signal processing comes in. Signal processing will help us understand the movement and figure out when you've hit something. So once the drumstick detects your movement, they'll send the information to a master device like your phone or the computer using Bluetooth. So then your device will play the drum sounds that match your movement. So when you swing your drumsticks, you'll hear drum sounds. So that is the basic project idea.
Good afternoon, Y23s. As you have got a wide idea of what our project is, you all will be wondering, why should I stay for 8 weeks to do this? Is it even worth it? Well, you will be learning a whole lot of new concepts like basics of signal processing, that how using signals you can gather information about the location of drumsticks, PCB designing, how you can convert your messy breadboard connections to a compact circuit board, and you will be learning about IMU and Bluetooth communications, UART communications. You will also get an idea about how accelerometers, gyroscopes, all these microcontroller works. Like you will get an idea about the working of microcontrollers throughout the project. And at the end of the project, we will be building an app. So you will also get app development basics.
So hello Y23s, here comes the prerequisite part, and I'm pretty sure that you guys must have got bored after hearing the word again and again. So here is something we want more than enthusiasm, that is sincerity. Like if you guys are staying back in the campus for 8 weeks, it is our responsibility that you get most out of this project, and it is possible only after your cooperation and your sincerity towards the project completion. And not only towards the project completion, towards a wonderful project completion. A little bit also, apart from this, a little bit of coding is preferred, and like basics of Python. Even if it is not there, we are ready to start from the scratch, and I'm pretty sure that you guys must have done ESC 111 and 112. So that is nothing. Apart from that, the weekly time commitment, that is 25 hours per week and 4 to 6 hours per day, and for 8 weeks. And trust me guys, this is worth it. Giving this time commitment, once you will see the project outcome, you guys will be proud of yourself after this air drums. Next, here are the mentors, that is Vanisha, Mansi, and me, that is Shreya.
Moving on to the second project, it is an AR gesture-controlled race car. So the main idea of this project is that we will be creating a car which is controlled using a hand gestures. And that car is equipped with a camera which will be sending that feed to your phone so that you can view that feed on a VR headset and then transport yourself to the location of the car. And just to make it more interesting, we will also be integrating AR elements onto that feed so that you can have an interactive race track experience. So basically, this project will be done in stages. The first stage will be to create a race car, and that have various things like steering, acceleration, and all of that. Secondly, we will be creating a glove equipped with flex sensors. Flex sensors are nothing but just basically they work on the principle of potentiometer, and they help to track the scrunching of a hand so that you can detect various different hand gestures you make. So secondly, we'll be creating a glove so that you can create gestures and then detect whether you want to accelerate your car, steer your car, or switch on lighting on the car, stuff like that. After that, we will be adding the camera to the car and then trying to get that feed on the phone. And once we have achieved that, we will be creating an AR app in Unity, which you will use to add certain elements of the car. So basically, the aim will be to create an interactive and fun racing experience for you guys. The major learning outcomes of this project will include computer vision. This will be required for tracking the markers and overlaying the AR elements accurately. Secondly, you will also learn about the working of microcontrollers such as Arduino and Node MCU, which will be needed for gesture recognition. Third, you will also learn about AR app development using Unity. And the major aspect of this project is going to be communication, because you will need to communicate between the glove and the car, and also between the camera and your phone. So these will be some things you will be learning throughout the project. There are no necessary prerequisites for this project, and the weekly time commitment is also around 20 to 25 hours. So you can assume that it is around 3 to 4 hours per day. The mentors are going to be me, Devansh Nunsen, along with me, Archit Mahajan, and Devansh Agrawal will also be co-mentors. Over to you.
My name is Rohit Verma, and the next project we are going to be offering is called Securing Ethernet with FPGA-based Encryption. Now, FPGA, that's a new term you must have heard. What are FPGAs? Basically, FPGAs are integrated circuits that can be programmed after manufacturing to perform specific functions. They offer flexibility, allowing users to configure the hardware to suit their needs using software tools. FPGAs are used in a wide range of applications, including telecommunications, signal processing, industrial automation, and more, due to their ability to provide high-speed processing due to parallel computing. Now, our project revolves around securely transmitting videos between FPGAs using Ethernet communication. The system uses a USB UART interface to download video data into one FPGA, where it undergoes AES 128-bit encryption before being converted into Ethernet packets. These packets are then transferred over an Ethernet cable from one FPGA to another, where decryption occurs, followed by a display over a VGA monitor. This is the kind of innovative and impactful work we'll be doing in this project. Next slide. So enough text. This is a basic high-level overview of what we are going to be doing in this project through these images. So first, you're going to load your video files through a laptop or any device to your first encryptor FPGA using a USB UART interface. In this encryptor FPGA, whatever data packets you have sent will be encrypted using 128-bit encryption and then transmitted via the Ethernet cable to another FPGA. Now, during this transmission, if anybody taps into your Ethernet communication cable or tries to take messages, what they're going to get is just pure noise, something resembling static white noise, because the whole data is encrypted. Now, after the data gets transferred to the second decryptor FPGA, once you provided the right key of decryption, these data packets will be encrypted data packets will be converted into meaningful video files which we have sent to the first device. And to show our capability of decrypting and encrypting, we'll be showing the videos on a VGA monitor. Next slide. So due to parallel processing and ultra-low latency of field programmable gate arrays, the whole project will almost be real time. From the moment you send the video to the moment of encryption and decryption to showing it on the VGA monitor will be almost real time, and you will have almost zero latency. Now, this project offers a unique opportunity for interdisciplinary learning. You'll not only delve into digital design and engineering, but also explore concepts in cryptography, protocols, and system integration. Now, the things which we are going to be focusing on in this project, I have listed them in a paragraph below: hardware design principles, memory management, real-time processing, interfacing, FPGA programming, complex algorithms like AES encryption, decryption, development of communication protocols, UART, Ethernet, and of course, cryptography. The project has it all. Next slide. But if I had to break down all the learning outcomes which I stated before into major domains, they would be digital electronics, hardware programming language, AES encryption standard, FPGA programming, Ethernet and UART and other interfaces, and embedded systems. Next slide. Now, prerequisites. I'm not going to say into obviously, but on the contrary, I would say this: if you take this project, I can guarantee you will ace your EAC 201 second half of the course next year whenever you take it. And because the learning outcomes are so many, you must have a zeal to learn. And you should also like challenges. because the project is going to be challenging in a fun way. Because if not, then what's the point of it? But I'm sure you'll be able to curb all of it with ease and have a very fun time in this project. The weekly time commitment will be around 20 hours per week, averaging 3-4 hours per day. Next slide. Now, the mentors of this project are Sopvik, Ritul, and myself, Rohit. If you have any questions, please check out our Discord server. We'll have all the informations and contact information there if you want to talk to any of the mentors about any queries you have. Thank you very much.
Hi everyone, myself Shivang Agarwal. The project title is EMG-controlled shooting game. Next. The project idea is basically we are going to create a game, a shooting game in which we will also make a game controller so that we can control the game using our hand gestures and the movement of our hand. Basically, we will make a sensor glove consisting of IMU sensors and the EMG sensors, which will be mounted on our hand. The readings of the IMU sensor will be mapped to the Arduino so that the movement of our hand in the real world will be mapped to the movement of the gun in the game world. And the actions of the gun like shooting, reloading of the gun will be controlled using the EMG sensor. EMG sensor is basically the sensor which is used to detect the muscle movements of the body. So whenever we make a gesture through our hand, it will get recognized by the EMG sensor and the data will be transferred to the Arduino. And in the second stage, we will expand our project to more general controllers where we will make use it as a general PC controller like a mouse or joystick, so that you can use it for as a cursor, scrolling and right click, left click, etc. The learning outcomes of the project are signal processing, FFT, noise reduction, filtering of the signal, EMG and IMU sensor fusion. Basically, we will learn how to implement multiple sensors together, working of the microcontrollers like Arduino, BLE, Arduino LilyPad, etc. Serial communication between the Arduino and Python, and game development in Unity game engine. There are no as such prerequisites for the project, but the main important thing is your Enthu, and the basic of Python and Arduino will be preferred in the project. The weekly time commitment we expect from you is 4 to 6 hours a week, a day, and 25 to 28 hours per week. The mentors are Sopvik Majumdar and myself, Shivang Agarwal. Thank you.
Hello all. This is Likith and I'll be presenting the project from Robotics. This is a project which we'll be offering in this summer. The project idea basically encompasses into two things. One, we are going to build a multi-terrain robot. Multi-terrain robot as in it can climb walls, it can do many maneuvers, and it can contain some sensors, and it can contain many important it can gather many important information from the terrains it is maneuvering upon. To achieve this goal, we'll be building an in-house PCB which will house all the sensors, microcontrollers, and all the control systems that are required to control this small, extremely small robot which we're going to build. And then we'll be developing an IMU-based localization system. IMU is the accelerometer and gyroscope sensor which can basically sense your motion. We'll be using its reading to, like localize our path, to detect the path on which we are going and establish a relative distance from a main source point. Using all this, we'll be able to gather some very critical information using this small set of robots. And once we have set up this system of small set of robots doing this, doing the tasks autonomously, we'll be connecting them to a major motherboard. And the eventual goal of the project would be building a robust system that will give the bots autonomy to make small decisions and help like the mother will be the motherboard or the major part will be giving them information on how it will how what task to do and what is the next step to take, right? So there'll be a hierarchy in decision. We'll have to develop a hierarchy in decision making and use this hierarchy to make solve complex tasks very easier. So the project will be eventually building a whole swarm robotic system that can be like easily enacted into any use case and made it can be integrated anywhere easily. Next slide, please. So some learning outcomes of this project would be you'll be learning a lot of mechanical design because you'll have to be building extremely small bot and you'll have to use additive manufacturing for that. Most mechanical design in this project is gonna happen on Fusion 360 or SolidWorks. So you'll be learning on how to do the stress strain analysis of the whole body and stuff. We'll be doing a lot of PCB designing. We'll be building extremely small PCBs that can do very complex control systems. And we'll have to implement a lot of ROS on how do you set Hello, I'm extremely sorry for the interruption. Am I audible now? Can someone come?
Yes, you're audible. You can start.
Sorry. As a part of this project, we'll be doing some networking on establishing connections with the small bots and using this, establishing the data flow to and from the server across the motherboard and the small bots. So, next slide. The prerequisites for this project would be N2 and pure resilience. You will have to be extremely resilient on on the course of, over the course of the project on how things progress and the core zeal of doing the things from corporate is very essential for this project. And this is a slightly bulky project, so you'll need at least 28 hours per week, which is closely 4 to 6 hours a day. We are flexible with this, but eventually 4 to 6 hours a day is something you'll have to commit to be a part of this project. I'll be mentoring this project along with Surya Shukla. Another project which I'd like to present is Voice Mode Companion. This is also a 7-week project which we'd like to propose. the project would involve deploying an LLM on single board computers. Right? Single board computers are Raspberry Pi, Arduino, and Nano. These are all the computers which are the size of your hand. Right? They are on one single PCB, and we'll be deploying an LLM using model quantization methods and we'll be using some particular set of weights and deploying this LLM on edge-based computing devices. And then we'll be doing Arduino classification on Arduino Nano BLE. Audio classification on Arduino Nano BLE. Arduino Nano BLE is like a small microcontroller which is the size of your thumb. So on such a small device, we'll be doing audio classification, as in we'll be detecting some particular parts of your voice key. Hi Siri. Yeah, hi. So, and after this, we'll be doing audio speech recognition again on the single board computers. This is a slightly bulky task. We'll be looking on establishing this on a single board computers. And after this, we'll be communicating this selected section of audio from my Arduino Nano to my single board computer and deploying it into the LLM. And getting feedback from the LLM and displaying it on both visual and audio means. Audio means is via microphone, and visual means is going to be via via touch controlled mirror. The mirror is going to have a monitor behind it. It's going to be a two-way mirror. We'll be building this smart mirror in-house, and we'll be deploying this. We'll be showing the output from our LLM onto this smart mirror. Next. Some broad learning outcomes of this project would be natural language processing. We'll be doing a lot of natural language processing over the course of the project on how we deploy the LLM, how we fine-tune the prompts that we are going to give to the LLM. We'll be doing a lot of audio processing on audio classification and many other things which we'll be using in this model. LLM and quantization, we'll be using LLMs, and we'll have to work on how to quantize these LLMs so that they fit in our size barrier which our single board computers have. And we'll be learning a lot of machine learning. You'll be learning on how they're implemented in this NLP and audio processing. And image processing is also going to be essential for the eventual touch interface which we are going to build on on the mirror. And this is going to be overall learning outcomes in this project. As a part of this project, I would want you to be extremely curious on how you can use every bit of the single board computer. Be very enthusiasm is anyways preferred. 24 hours per week is something we'd expect from you to be a part of this project. The mentors will be me, Shivang, Utkarsh, and Ashwini. This is the whole motto of our summer project. This summer, please be here to build something that you'll be proud of for your lifetime. With this, we'd like to end our presentation for Summer Projects of Electronics Club. In case of any queries, please reach out to us on Discord. We'll have all the mentors, and we'll have separate channels for each and every project out there. Please ask your queries, and all the further logistics on how the projects will function will be discussed on the Discord itself. Recruitment and all the process will happen on Discord, and you'll be informed timely on the club official Y23 groups and the club any other official club. Thank you.
Great presentation, club. I guess now we move on to the FIC. So, Finance and Analytics Club, over to you.
Am I audible?
Yes, Tanashi, you may begin.
Yeah, sure. So, hi everyone. We are the Finance and Analytics Club, and this is a summer projects presentation. So, we are planning to offer 7 projects this summer, and we have exhaustively chosen different projects in different domains so as to provide you a bucket full of resources which you could use to ease out your financial journey. So, let's move to the first project, Quantitative. Yeah, thanks. Yeah. So, Quantitative is basically a web-based backtesting engine, And this project will be mentored by me, Tanush, along with Rajit, SnT and Divit. So let me just firstly introduce you to what the project is and then move on to the minor details. So in Quant, what we mostly do is that we develop a trading strategy, and based on the trading strategy, we enter the market and exit the market, right? So mostly in the trading strategy, when we are implementing it, what we do is we merge different risk management measures with that strategy, so as to basically maximize the profit, because that risk management measure basically tells us that when we should exit the market at a more appropriate place as compared to a normal trading strategy. So the first part would be to teach you that the basic trading strategies implemented using the risk management measures. This would range from normal candlestick patterns, technical indicators to sophisticated ML models. And then the major part of this project will be devoted to building a testing engine. So these are the main key features of the testing engine. So let's say you have developed a strategy. Now, how would you assess that the strategy is working well? So the obvious way is to test it on the real market. So there are two types of testing. One is the live testing and the other is the back testing. Let's say you developed a strategy. So you have the past market data available to you. So when you, let's say I developed a strategy today in 2024 and I backtest it on 2021 to 2026. So that is called as the backtesting, in which we test the strategy on the previous market data. And live testing is when we scrape the real market data from, let's say, any common website. And based on that, the strategy is executed and the website is dynamically updated. Apart from that, the testing engine would also host create your own strategy and create your own risk management, which would include some guidelines as to how the strategy should be formulated in Python. And then the testing engine would be able to evaluate that. So after the completion of this project, the mentees would be able to have solid web development skills, because the website would be executed in HTML, CSS, JavaScript in the front end and Java in the back end. Apart from that, they will also develop web development skills, web scraping skills, and how to write strategies in Python using this. So yeah, over to that.
Yeah, am I audible? Yeah, okay. So here is a brief timeline of our project. So for week 1, we'll be starting off by coding trading strategies in Python. So this will be the basic idea of how to code strategies based on some indicators and signals. After coding these strategies on Python, we will start to build a backtesting framework for that in Python itself, so that we can get to know a better idea about the metrics of our strategy, such as the Sharpe ratio, drawdowns, risk return, etc. In week 2, we'll start completing the backtesting engine and evaluate the performance of week 1 trading strategies, which we have implemented before. Then we'll start introducing the risk management measures for the strategies, which range from simple conventional measures such as stop loss and take profit to other sophisticated risk management measures, so that we can minimize our drawdowns and maximize our returns for the strategy. From week 3, we'll focus our working part to the web development part, and we'll start learning the basics of web scraping. So for that, we'll require to learn some of HTML, CSS, and JavaScript. And in week 4, we'll start learning Django, so that we can start preparing the front end and back end. For week 4, we'll start preparing the front end using the HTML, CSS, and JavaScript parts learned in week 3. And in week 5, we'll merge that front end with the back end using the part of Django which we have learned. And we'll create a sign-in and register option for user privacy for the framework. And in week 5, we'll also try to work and merge the backtesting engine with the front end of the project. Once that is integrated, in week 6, we'll create sections for creating our own strategy and risk management measures. So apart from the trading strategies which we have covered in week 1, we'll also add some other trading strategies and other risk management measures in week 6 and try to integrate them with the website as well. And once we integrate them with the backtesting area, a brief model of our project will be complete. And in week 7, we'll just work on building the live testing section. Also, after that, we'll work on the documentation for the website as well, so that we can have a comprehensive idea about how our website is going to function. And in week 8, we'll focus on working on debugging and evaluating test edge cases for our website. And once that is done, we'll finally deploy the website using Python Anywhere, as it is a Django framework. And finally, after deploying the website, we can check the functionalities we have covered. Yeah, so I can go to the next slide. Yeah, so here are some prerequisites. First of all, you just need N2 for the project. If you have familiarity with Python, then that would be good, since most of our project will be covering Python, also all the trading strategies as well as the Django framework, both are in Python. The time commitment would be around 14 to 16 hours per week. So we expect you to work around 3 to 4 hours every day. And familiarity with OOPS would be a plus point. So if you know object-oriented programming in Python, that would be a plus point. But even if you don't, then we'll try to cover it throughout the project itself. And this is not necessary as such, but a basic familiarity with Python is needed. And yeah, so the most important prerequisite is N2 itself. So thank you. Here we end our project.
Am I audible?
Yeah.
Okay. So the second project of FSC will be Marketing Insight. It would be mentored by me, Akshat Chokse, Tarun Sridhar, and Mitesh Kulparia. Tanush, next. Okay. Now coming on to the Waters project. Our project is basically around trading. The first thing that comes to anybody's mind after hearing the new Finance and Analytics Club is trading. So this project will be covering all the core concepts of trading, including various markets. The markets which we are going to cover are stock market, derivatives market, commodity market, crypto market, forex market. What we are going to do in this project is covering all the basic details which are required for trading. That includes your technical analysis for a company, fundamental analysis. In fundamental analysis, we will be diving deep into company's balance sheet, its annual report, and all the various things related to its financial analysis. The project will also be covering option strategies, the derivative market in complete, the future contracts, forward contracts. And in this project, you will have a 1 month trading competition in the second half of this project. You will be provided a platform on which you will be doing the virtual trading. Also, we were planning to have a session after every assignment to help you understand about. Fine. You will also have presentations, bi-weekly presentation on the topic which you are learning. We will also have financial discussions bi-weekly. What basically you are going to do is we will be teaching you all the concepts which are required for you to have a better grasp about trading. And you will actually have to commit 2 to 3 hours daily for learning all the concepts related to this. Next page. Okay, so this project is actually not about making you learn all the theories of finance, but to actually make you understand how to apply all those theory in the real life. Move on to time. Okay, so in the first week, we will be introducing you to the basic of fundamental analysis. In the second week, what we are planning is you will be given various case studies to work upon related to the fundamental analysis of a company. In third week, we will be diving into technical indicators plus the various theories which are around technical indicators and how to apply those on the real market. On the week 4, we will be completing up with technical analysis and moving to the derivatives market. After that, you will have your, after second week, you will have your actually first midterm eval assignment, in which you will be divided into a team of 4. You will be given a company, you have to do a proper analysis of that. We will be helping you how to figure out that, and you will have a debate and presentation around that. In the week 5, we are planning to start off with the actual option strategies and the option market. In the week 6, we will be competing with option strategies. After this, you will be capable to actually develop your own strategies around options and derivative market. And around the 5th week, you will have your final trading competition started, which will be a month-long competition in which you will have your virtual portfolio of 10 lakhs and you have to invest accordingly. In the week 7, we will cover different markets like commodity markets and all. And in the week 8, we will be wrapping up with finally forex and crypto market. In week 8, we will also have discussions on topics which were left or you think that this should be taught again. Next. Okay, so there are no as such prerequisites for this project. Your basic interest, like you should have Antu, like the basic thing required for this project is Antu. The time commitment would be 10 to 12 hours for the first one, and after you start trading, after first month when you will actually start trading, you will require to give 3 to 4 hours daily for this project, because actually you have to read all the you have to actually understand what's going in the market in the real time, like from 9 to 4:30, 3:30 on the NAC websites, what's going on the market. The time commitment for the second half of this project would be like 14 to 15 hours per week. Okay, thank you.
Hello, am I audible? So the next project of FSC is Algorithms Insights. This is basically a project on quantitative trading and portfolio risk management. So most of you must now be aware about trading and stock market. I guess most of you will also have heard about quant firms, HFTs. You must have heard why their packages are so high. So this project is basically an introduction to the world of quant and to algorithmic trading. So in this project, we will discuss what the trading firms actually do, why they don't involve any human decisions in their strategies, and how do they actually trade using just computers and algorithms. We will be building some programming algorithms based on various strategies, technical indicators, chart patterns, and we will see how we can implement them, and let's hope you will make some profits. Next slide, please. Yeah, so in the project, we plan to develop at least 3 different kinds of trading strategies. We will be coding all of them in Python. We will start everything from the basic, and we will also discuss some evaluation matrices. Suppose you have developed a strategy, now how do you evaluate it? Is this strategy better or the other strategy is better? If I am given a particular condition, then which strategy is better? And we will just deep dive into all the algorithmic trading patterns. We will also be using some candlestick chart patterns to generate buy and sell signals, and we will then backtest them on the previous data. Next slide, please. Yeah, so from week 1, we will discuss some mathematics, some probability theory, and Python libraries like NumPy, Panda. We will teach the basics of trading, finance, and risk management. From week 2, we will shift our focus to the coding part of the project. We will discuss technical indicators like MACD, EMA, which don't worry, you must not know them now, but you will know them when you are in the project. Sharpe ratio, Sortino ratio, all these matrices are used to evaluate a strategy, and we will first discuss them. Then everything will be coded in Python. You will get enough time, and each week we will be releasing an assignment which will be based on the topics taught during the week. Week 3, we will discuss some trading strategies like mean reversion, pairs trading, and we will discuss their benefits, when one strategy is used and when the other is used. Week 4 and mid-eval will consist of coding a final strategy and incorporating stop loss and other risk management techniques, which we will discuss. In week 5, we will go to the risk management part of the project, where we will discuss which portfolio is better and how can we minimize our risk involved in a portfolio, at the same time maximize our profit in a portfolio. We will be discussing credit score modeling. We will introduce you to VR, and week 6 we will go to risk mitigation strategies and stress testing. Week 7, hedging. You might have heard about hedging strategies and how they are used to minimize the risk. And week 8 will be just something related to ML. Monte Carlo we will discuss, and we will end the project with end-eval. Yeah, so what are the prerequisites for the project? N2, It's just the most important part, and we will appreciate if you are familiar with Python, but basic coding knowledge which you might have got in ESC 111 also works. Expected number of mentees would be 15 to 20, and time commitment for the first part of the project, that is for the quant part, it will be approximately 14 to 15, and the second part of the project would be on a lighter end. It will be around 6 to 8. We have just written the average here, and yeah, this project will be introduction to the quant world, how we create a portfolio, how the quant firms actually trade, how do you create a algorithmic trading strategy, and yeah, we will learn together. So
I would like to add on. Yeah, I would like to add on something that for the first half you will do all the things related to quant, and for the second half you will learn all the risk management strategies and how do you evaluate a risk and how do you make portfolios and all of this. So I think this will be a perfect blend for your fundamental as well as technical side of the finance.
Yeah, if you have any doubts, you can feel free to reach out. I am Prakhar, and this will be co-mentored with Moni and Rahul. So yeah, thanks.
I hope I am audible. Yes, Naman. So the next project being offered by FSC is Quant Plus. So the project involves basically whenever we analyze a stock, there are two ways to analyze a stock. The two ways are fundamental analysis and technical analysis. Fundamental analysis involves analyzing the company's financial health through certain metrics such as which are usually derived from the company's balance sheet and stuff like that. And technical analysis involves examining the market trends, the recent market trends related to the stock. So initially, we are aiming to use machine learning on fundamental and technical analysis to take decisions for trading in the market. We'll employ fundamental data analysis, machine learning, and sentiment analysis techniques to develop stock price predictions, enabling informed investment decisions throughout our project. So the objectives and goals. Initial objective and goal is to set up a financial base, which comprises of fundamental and technical analysis, obviously. And then we move on to learning to use machine learning and natural language processing to make predictions about stock prices and take trading decisions accordingly. We aim not only to learn to apply machine learning models, but also to understand the math behind machine learning models and NLP, so that to develop a proper base essentially of the mentees. We'll finally use sentiment analysis to gauge the stock sentiment, and we'll mix that with technical analysis to create very useful models in the market. So the week-wise roadmap, initially in the week 1, we aim to introduce the mentees to fundamental finance and Python, along with machine learning. We'll start with machine learning. You are expected to know Python before the project starts, to some extent. Essentially, the project has two roadmaps. One is related to finance, and one is related to machine learning and Python. So every week we'll do stuff of both of finance as well as machine learning. So in the initial week, as I said, we'll start with fundamental finance and machine learning. Then we'll move on to we'll learn how to actually dive deeper into fundamental analysis of a company and how to make predictions, how to make investment decisions using fundamental analysis. And then we'll also start working on popular machine learning models and problem statements. In the third week, we'll work on fraud detection, and the mentees will be introduced to technical analysis of a stock. After that, in the week 4, we'll finally make predictive models using fundamental and technical analysis. We'll not make predictions here in the traditional method, but instead we'll use machine learning to make predictions using the data of fundamental and technicals. Finally, in the week 5, we'll move towards developing models for IPO prediction. So when a company is listed in a stock, or before a company is listed in a stock exchange, it essentially releases an IPO. So we'll develop a model to predict how the IPO will perform in the actual market. In this week, we'll also start with NLP, and we'll start learning the math behind NLP in the week 5. After that, in the week 6, we'll dive deeper into NLP and applications, and then we'll move towards developing a Python framework for trading. Both of these things will be happening side by side. And in the week 7, we'll learn how to use NLP for sentiment analysis of stocks. And finally, in the week 8, we'll combine the sentiment analysis of stocks model with the technical analysis model to develop to make predictions. We'll essentially create a framework which uses both NLP for sentiment analysis and technical analysis and technical indicators, which we have already heard in other projects. So that is about the project. The prerequisites are Enth, obviously. As I said earlier, the mentees are expected to be familiar with Python. Their knowledge of, if they already know ML, it's an additional bonus, but it's not a hard prereq as such. Other than that, the commitment will be around 10 to 12 hours per week. This is the baseline commitment, and it is expected to rise. That is it. We'll move on to the next project.
Am I audible? Hello everyone. Myself Tushar. This is yet another project by FSC, DeFi Unchained. The project will be mentored by me and SnT. Next slide, please. The project is going to be about blockchain. Blockchain is a decentralized and immutable ledger technology that has gained significant attention in the recent years. You must have heard about Bitcoin and lots of other cryptocurrencies that run on blockchain. In finance domain, undoubtedly, blockchain has found widespread application in various areas such as payments, remittances, smart contracts, and asset tokenization. In this project, you will get introduced to the science behind the blockchain technology, and we will develop a robust, secure, decentralized, stable protocol. Next slide, please. The objectives and the goals of the project. You will learn the mechanism behind the working of blockchain and its applications. You will be getting hands-on experience of using Solidity programming language and implementing smart contracts. And finally, you will be developing and scaling a DeFi stablecoin. Next. So this is the week-wise roadmap. In the initial weeks, we will be covering the theory part, and gradually we will be moving to the programming steps. In the week 1, we will see how banking e-cash transaction works, what is blockchain, what is distributed ledger technology. In the second week, we will be doing wallet setup. We will also see proof of work, proof of stake, and have discussion on Bitcoin white paper. We will also start with smart contract. In week 3, we will see the Ethereum white paper. We will also see decentralized finance, decentralized autonomous organizations, and decentralized applications. We will also see ERC20 protocol associated with Ethereum, and we will be starting with programming on Remix IDE. In the 4th week, we will be doing local setup of Solidity development environment, and we will do smart contract unit and integrated testing, NFT smart contracts. In the 5th week, we plan of doing Chainlink mock VRFs, virtual routing and forwardings. In the 5th to 6th week, we shall be doing minor projects on e-voting systems and flash loans. The week 7 and week 8 will be devoted towards our final PS, that is developing the DeFi stablecoin. Next. Prerequisites. Obviously, your enthusiasm to learn and explore the domain is really necessary. EC112 for familiarity with programming and C language. Use of ChatGPT and Google. This will be a great help during the project, and we expect a time commitment of 8 to 12 hours per week. And that's it. Thank you.
Am I audible?
Yeah, you're audible.
Okay. Okay, so quantitative finance and recommender systems based chatbots have been buzzwords for quite some time now, and our project Invest essentially tries to combine them. The mentors are me, Agam, Samyak, Shashti, and Kinchan. The end goal of this project is to build a chatbot which takes in a user's query and gives him suggestion on whether he should take a trade or not. The task seems fairly simple, but to build a framework like this involves incorporating several factors. Now, once we know what, let's get down to how. The key things you will be learning in building the framework would be the first, basics of technical finance, which is a combination of technical indicators, price action, and statistical testing. Also, we will be working a lot with portfolio optimization, so that would be an added knowledge. The second key learning would be basic time series forecasting, models like LSTM and ARIMA, and the working behind them. Additionally, we will be building a basic framework for combining users' query and response generated by a recommender system. So mentees would additionally be equipped with basic knowledge of web development and using open LLMs for human-like response generation. Next slide. The week-wise roadmap is as follows. In week 1, we will be teaching some statistical testing for identifying if the stock is trend following or mean reverting, teaching technical indicators like MACD, RSI, IBS, Bollinger Bands, and explore time series forecasting for LSTM and ARIMA. In week 3, we will teach the codes of them and explore parameter selection. It would be like brute force work. In week 4, we will be combining insights from every strategy and build a basic backend which gives us a response based on user's query. In week 5, we will be working with portfolio theories. In week 6, we will be assigning weights to different parameters and generate a more fresh code. In week 7 and week 8, we will be finishing off the development part, and we aim to build a basic chatbot which takes in users' input and gives suggestions based on his risk appetite and equity. Prereqs is the first and foremost, obviously, Enthu. Secondly, since a lot of part of project is in Python, so we assume that mentee should be equipped with basic Python. The time commitment is 8 to 9 hours per week, and plus familiarity with machine learning or development is a plus point, but it is not a hard prereq.
Coming upon the 7th project offered by FSC, it is displaying the decisions. The mentors for the same are Naman Gupta, Rohan Ram, and Ash. So what we all think is basically algorithmic trading is all about numbers and data. But ever wondered how emotions like fear and greed impact our trading decision? This project revolves around the behavioral finance and integrating cognitive biases into algorithmic trading to increase the decision-making accuracy. Next slide. Next slide. So the objective of this project is to include psychological factors into decision making while making trades. This will also include integrating game theory and emotions along with social influences into trading. So this is basically incorporating sentimental analysis into our trading so that our decisions are better and more human-like. Next slide. So this is the week-wise roadmap of the project. In the first 2 weeks, we will be covering the introduction to financial markets and basic Python, which will include learning libraries like NumPy and Pandas, and it will focus on indicators, derivatives, and coding trading strategies. The week 3 and week 4, we will dive into behavioral finance and explore how psychological factors affect the financial decisions. Basically, in this, we will try to incorporate humanly touch into our algorithmic strategies. In the week 5 and week 6, we will learn the application of game theory in trading and its influence on the microstructure of financial markets. It will take us to brief idea of what a behavioral finance is basically is. In week 7, we will cover the advanced topics covering complex system and agent-based modelings. In the week 8, this would be the final week for the project, and the mentees will design and test trading strategies and analyze market data for behavioral patterns, and they'll try to improve the results using sentimental analysis. Next slide. So the basic prerequisites for this, the foremost is Enthu, and basic Python knowledge is also appreciated. The number of mentees which we are expecting is around 15, and the time commitment for the same is 8 to 10 hours per week. So thank you. This was FAC, and we all await your participation in our summer projects. We will learn and grow together. Thank you.
Now we'll be moving on to Game Development Club.
Am I visible? Am I audible?
Yes, you're audible.
Okay, so hello Y23s. We are the Game Development Club of IIT Kanpur. We are a group of enthusiasts who are very interested in making games and exploring various domains like computer graphics and AI. And this is our presentation for the summer projects. So let's get going. So we'll be offering 6 summer projects this year in various domains. Like we'll be learning Unreal Engine. We'll be exploring AR, VR in game dev. We'll be making a 3D renderer complete pipeline, rendering pipeline in 3D graphics and shaders, using graphics and shaders. And we'll be using AI in games. We'll be making 2D and 3D art. We'll also be making sound design. And we'll finally, in project 6, we'll be focusing on game design and computer-human interaction. Beginning with our first project, this is Unreal Learning. We'll be exploring game dev in Unreal Engine 5. This project will be mentored by Kunal Shikhar, Abhishek Meena, and myself, Aryan Verma. Okay, so this is the basic difference between Unity and Unreal Engine. Unreal Engine offers much higher fidelity graphics than Unity, and it offers many framework and tool out of the box, which Unity does not offer. And Unreal Engine is basically better in making better AAA games than Unity. Okay, so in this project, we'll be understanding various components and various pipelines that involve in making a comprehensive game using Unreal Engine 5. We'll be specializing in various domains, programming, art, using procedural generation, and game design. And the takeaways for this project are proficiency in Unreal Engine. We'll be creating 3D maps using procedural generation. We'll be learning programming languages like C++ and Blueprint. Blueprint is Unreal Engine's own visual scripting language. And of course, we'll be doing game design and version control using Git and GitHub. First, we'll be diving deep into Blueprint scripting, visual scripting using Unreal Engine's own language. We'll be exploring object-oriented programming concepts, by which you can make one object and use it in multiple locations and cases that are required in game making. We'll be exploring enemy AI. We'll be making a basic enemy AI that basically counters and works against the player. And we'll be understanding the basic game framework that Unreal Engine comes with out of the box that are used in game making. We'll be committing 15 to 20 hours a week. Note that this time includes time for learning, for implementing stuff, for assignments and other things. And the prereqs, of course, it involves coding, and ESC 112 is preferred, and we'll be requiring a PC or laptop with a dedicated GPU because Unreal Engine is a pretty heavy software. It requires over 60 GB of storage space and requires very high computing power. Okay, so on the left, we have a simple shooter game we'll be making using Unreal Engine. And on the right, we have a realistic 3D map we'll be making using procedural generation. This is a short video which displays the power of Unreal Engine. This video demonstrates how powerful Unreal Engine is. Okay, so now my colleague Abhishek Meena will take over.
Thank you, Aryan. So our next project is Vision Robotics, Intro to AR VR in game development. So this project is first time offered in game development in IIT Kanpur. So myself, Abhishek Meena, and my co-mentors of this project are Ananya Dev Chaudhary and Aryan Verma. So, what is the vortex in this project? So, if you have seen Apple Vision Pro, you may be confused. Is this real, or like the spatial dimension of this? In what you see in the Apple Vision Pro, the eyes can't differentiate in virtual and the reality, the space in that Apple Vision Pro. So here you will also learn like AR and VR, so you can't differentiate between like reality and virtuality or augmented. So what is the abstract of this project? So you will learn AR development and implement interaction and object placement using frameworks like ZeroAR and softwares like Google's AR Core and Unity. If we would have enough time, you will also expand that to the Unreal Engine to make a more realistic game in VR. So in the first phase, we will learn AR development and try to teach and to interaction in AR placement, AR world, and how to use ZeroAR and implement geolocations in your campus. In the next phase of the project, we will transition to the VR development, VR game development, and more focus on like locomotion and optimization of VR game. So what is locomotion? Locomotion is a spatial, like the VR space displacement. So firstly, we will try to teach locomotion and optimize that mechanic in the VR games, and try to implement animations in VR space. So what are the key takeaways of this project? So firstly, you will learn obviously you will learn AR and VR game development, and how will you implement that in like your software in your PC. You will use Google's AR Core in your mobile phone to implement AR world in your mobile, to directly connect it your laptop with like Unity and stuff like that. So you will need programming languages like C# and C++ to use in this project. What are the agendas of this project? In the final product of this project, you will have AR and VR game with basic interactions and tapping in spatial spatial dimension, and implement object placement and object interaction in specific locations in your campus using frameworks like ZeroAR and Google AR Code. So we will require you to dedicate your 17 to 18 hours per week in this project, and there are not such prereqs in this project. Like you will not need that much of programming in this project. Basically, there are much like testing in this project. Like you will need more time to test your game, to implement that in your special configuration. So yeah, you will have to invest in AR and VR game development. So firstly, in the left you can see Pokemon Go. You have seen Pokemon Go. You may have played. Like this game heavily use ZeroAR to heavily implement ZeroAR to make their game. So like you can see ZeroAR is used on the on all over Earth. So yeah, and the VR part, you can see VR escape room. You can see you have to have more precise object interaction to escape this room to complete that game. So yeah, we will try to teach you to optimize how to optimize interaction and spatial displacement in the game. You can see what this Pokemon Go is like.
My nose is ridiculously stuffed up and I sound like hot garbage, but whatever, let's do this. Pokemon Go is getting a new AR Plus mode, and it makes the game augmented reality a bit more real. Niantic first mentioned the new improved AR mode way back in June at WWDC, but finally set to roll out later this week. In the game's original AR mode, Pokemon was supposed to float on the
see here is
most players turned it off.
more precise
the new AR Plus mode, Pokemon
ZeroAR is
AR relative to the real world. As you get closer, they're going to get bigger. You can sneak around them, or you can get very close. Getting closer makes it a bit easier to get those very close with your Pokeball, but if you move too fast, the Pokemon are going to get scared. If you can get close enough without spooking them, expert handler mode kicks in, giving you a small catch rate bonus along with
thank you, and I would like to hand over this to Nevish Patel.
Am I audible? Aryan, am I audible? Aryan, am I audible? Yes, you are audible. Okay. Yeah. Good afternoon, everyone. I am Nivish, and I'll be presenting you the next project of Game Development Club, which is graphics and shaders, 3D render. And along with me, I have my colleagues Harshit and Naman, who would be the co-mentors in this project. So, graphics. Now, what is computer graphics? So, what is computer graphics? Computer graphics, or CG, is basically graphics generated by computers, right? With a bit of math, actually a lot of math. And shaders. Now, what are shaders? So, I'm sure you must have played many games, but there are a few games which feel a bit flat. No, that's where shaders come in and spice things up. Now, shaders are basically small programs which run on a GPU and not on our CPU. But why does it matter? You can see the meme itself. We have a Drake meme here, which says basically math on CPU and math on GPU. Now, what do shaders do? Shaders add all these realistic lightnings, shadows, and textures which make a game pop up. Right? I mean, I would love to play the game which is with all of these added stuff and all. Yeah. Now, I'm sure you'd be curious to know how these things work, and we are going to do exactly that. So, we'll basically understand how computer actually renders graphics or generates graphics. We learn more about lighting models. There are various lighting models, diffusion, spectre, and all. And we'll also be learning the use of OpenGL. As I said, shaders are programs which run on a GPU, so we need something to communicate with it, which is exactly what OpenGL does. And the key takeaways from a project would be the understanding of rendering pipeline. Now, what is rendering pipeline exactly? Rendering pipeline is basically all the steps our code goes through to transform it into these visuals. Now, we will also write many shaders, many different types of shaders. For example, geometry, vertex, fragment shaders, which basically form a part of our rendering pipeline itself. And we'll also learn about different lighting models, as I said. And of course, we'll be using OpenGL to make our render. And we'll also be writing some actual shaders which can be used in our games. And as we're making a renderer, we'll also be teaching C++ development. Yeah. So, all in all, we would be creating a renderer like this, and this would be your own renderer from scratch, which would be capable of handling different types of lighting models, image filters, and also importing various 3D models and other translation and other mechanisms. And we have lighting models here, yes, as you can see. So yeah, we'll be building a complete renderer of, as I said, of various features, and weekly we'll need a time commitment of about 15 to 20 hours. And as I said, there are prereqs, as it includes a bit of math. It requires ESC 112 and ESC 111, and a bit of vector maths, and obviously a lot of N2. So yeah, this was what all about CG was about. I'd like to call Kunal, and thank you, Aryan.
Thank you very much, Nivish. And for now, I'll be joining you for the next project, which is Smart Games and AI. So the project mentors for this project would be Uday, Harshit, and me myself, Kunal. So let us move on. So basically, what is game AI? So the basic idea about game AI is that how the NPCs, enemy AI, the bots, and everything works in the dimension of games. That how is the everything that you have seen in a game works. Have you played God of War and other games, or basically a chessbot even? There are many different types of functioning and AI which is working behind all of that. So in this project, we'll be learning to make how that AI works, and we'll make our own project in which the enemy AI, the NPC, or anything works. So basically, the key takeaways of this project will be minimax and alphabetic cloning algorithms. Then there will be RL algorithms like Q-learning and other type of things that will be there in the RL present. So the basic agenda of this project will be to make a final product as a deliverable, which would be a game in which different kind of things would be different kind of AIs would be present depending upon the structure and interest of the maker. So basically, there will be a game at the end in which there will be different kind of things like an enemy AI, an NPC, a bot, which will be working behind it. So the time commitment for this project is nothing much as we are talking about it. It will be just 15 to 20 hours, which will just fly away as you work on it. And it is a very interesting topic to learn about. The prereqs are nothing much but a basic idea of recursions, which I think that you all might have learned through the ESC 112 course, and basically Nth. Nth is everything we want. And at the end of this project, you will see the most AI thing that you won't be able to beat your own AI. Just like this. So now I would like to call Harshit to take over from him.
So our next project is Game Art and FX. The mentors of this project are Rudrash Kauder and Ananyadev Chaudhary. Next slide. So basically every game, like what makes the game playable is its art. If the game does not have good art, whatever good the mechanics be, like however good the game be, if without good art, any game is always bad, right? So for our club, we need to have like good art for each of our games so that the playing experience is not like very bad. So this is the project where we will teach you guys how to make art, how to make animations, how to add sound to the game, and how to add other stuff. Next slide. So in this project, we'll specialize in game art, and it's like 2D and 3D, how to make 2D art and 3D art. We'll also understand character design, game design, how to create an environment, like how to add animations to a character you just created. We'll use Blender for 3D assets, Illustrator for illustrating us, Photoshop for making the backgrounds and the asset, Animate for like the animations, and Unity Shader Graph we'll use for visual effects, and we'll use FL Studio for introducing some basic sounds into the game. Next slide. In this project, you'll basically learn art sketching, modeling, animating, and you'll also learn about 2D sprite sheets and character rigging and texturing, which will create cool graphics in the might have seen in our favorite games. The time commitment for this project is 15 to 18 hours, because most of it will be like hands-on. You will have to do all the stuff yourself. There will be very little of theory, and the only prereq for this is like into in art, into in game design, game development, and interest in game art.
Okay, so next we have Chai Play, which is a project that targets Chai Play Conference of 2025, and this is primarily based on designing games, that is game design. This project will be mentored by Akshat Raj and Shashikant Yadav. Okay, so this project is primarily focused on game design. We'll be exploring design principle and the whole development process that is needed in game development and design, and how to make the games more engaging and collaborative. We'll focus on mobile gaming for this project. We'll be learning how to create user-centered design, how to make engaging and interesting games, and we'll be also be talking about how we'll be testing and basically reviewing games. And in this project, we'll also be improving our creativity and problem-solving skills. Okay, so the main aim for this project is making a playable game for submission that gives an innovative solution to the problem for the Chai Play 2025 conference. The time commitment for this project is pretty decent, about 6 to 8 hours a week, which will primarily involve discussion and debating about game design. Note that this project will be in completely online mode, and there is not as such prereqs for this. Only thing that is required is N2 and interest in game design and games in general. This is a small video that demonstrates how you can interact with James 10. Basically, here we're talking about how to teach kids like about gates and moving gates and stuff. This was our project outline. We have these are our 4 coordinators: Abhishek Meena, myself Aryan Verma, Harshit Sharma, and Kunal Shikhar. Our Discord IDs are given as under. These are all the links to our social media handles, and the QR leads to our link tree. So thank you. May we have a great summer ahead. Hoping to see you all in large numbers. Thank you.
Thanks. Now we'll be moving on to ICG projects. कौन है? Shara.
Hello. Is it visible? So hello everyone. We are ICG. We are a group of data analysts and consultants who are driven to use machine learning and consulting techniques to solve problems at a social level. So here are our projects. Okay. So first of all, we have deep dive to transformer and its applications. So basically in this project, we want to give our mentees a taste of what machine learning is, starting from the scratch and taking it all the way up to transformer architecture, where we shall explore deep in theory what transformer actually is, what it does, and along the way obviously we'll explore basic ML as well, so no need to worry about that. And for we shall conclude with some interesting applications with the help of transformers, so that you can get get hands-on experience and get a taste of what doing machine learning and AI is like. Okay. So here are the key features of the project. So obviously we start with the basic and ML basics, and then we cover everything that has occurred before the bringing up of transformers. Then we jump to transformers themselves, and then applying to learn, that is the applications. For example, all of you know about ChatGPT and speech recognition models and object detection and image to text. So yeah. These are logistics of the project. This is a relatively tougher project, and we'll be expecting a commitment of at least 12 hours per week. So keep that in mind. We are expecting 50 to 20 mentees in this project, and the duration will be of 8 weeks. Yeah, so it's a lengthy project. And for the prerequisites, we require basic Python knowledge with exposure to libraries such as NumPy, Pandas, and Matplotlib, and also basics of machine learning, if they are known beforehand, would be appreciated. And obviously, Enthu is a must. That is the base requirement, right? These are the mentors. You can take note of their contact numbers and contact us anytime if you have any queries. So moving on to the next project.
Okay, so good evening everyone. Our project is customer churn analysis from data to strategy. So first of all, what is churn? Churn is the number of customers that a company is losing. So we'll try to predict that for a company using machine learning, and we'll try to apply this to the real life problem of, okay, so once you have churn, how do you actually solve it? So then comes the consult part, where we'll try to market, we'll try to tailor marketing strategies for segments of customers. And we'll use various frameworks also for this. Moving on to the next slide. So there are key features of the project. First of all, we learn about Python and machine learning basics. So if you have familiarity with Python, that's good, but regardless, we'll be covering it right from the beginning. We'll do some machine learning terms and libraries like NumPy, so the mathematical part will be covered. You must have heard of Matplotlib and Pandas, so we'll cover that also. That will cover the data plotting aspect. And then we'll talk about TensorFlow and sklearn, the machine learning libraries. And we'll understand what churn is and classification is. So I already explained a little bit what churn is customer losses for a company, and how we'll actually predict it will be through classification. So there are various models that we can use, and we'll try to find the best one. Then comes feature engineering and classification for churn prediction. So since we have a lot of features, we'll have to pick the ones that are the best, and we'll also be converting our categorical features into numerical features because that enhances the accuracy of the machine learning model. So we learn some feature engineering techniques, and we will use classification models to predict churn rate. Then explainable AI. So lots of times when you have a machine learning model and you have some data, you're inputting that, and then you're getting the output. Sometimes it's a little hard to understand how exactly the machine learning model came up with the results that it did come up with. So there are some methods. There is the Shapley method. So what you do is that you apply these explainable AI methods, and then it's easier to understand how the machine learning model came up with the results that it did. So for example, you have a feature that is negatively impacting the churn value, that if this feature is high, then the churn value is likely to be low. Or if you have a feature that is lower in value, then it is possible that this customer is more likely to leave the company. So we understand how different features affect our final output using Shapley values and other explainable AI methods. Over to Ritik.
Okay. So we will be working on data from a certain company of a sector such as telecom. And on this, we will apply various analytical methods to find out customer segments, to find customers that will result in high revenue, but are also at the risk of high churn. Following this, we will be tailoring marketing strategies. Now, these marketing strategies will be analyzed through various frameworks such as the SWOT analysis, which is strength, weaknesses, opportunities, and threats. Then we will get to know what are the best qualities of a certain strategy and what are its pitfalls. Followed by this, we will apply the strategies to the model in real time to understand what its effects are. The project will be nearly divided between 50% consult and 50% ML in terms of efforts. Duration will be 7 to 9 weeks. The expected number of mentees is 15 to 20, and the workload will be around 10 to 12. The only prerequisite is enthusiasm. Basic Python is appreciated but not necessary. We will be teaching most of it in the first week as well. These are the mentors, the Discord ID, and the numbers are given. You can contact us on Discord as well as on WhatsApp. On to the next project.
Hello everyone, myself Abhishek. So our project is cycle GANs translating images. So have you ever imagined how cool is it to transform the photos from one domain to another? Say in this image we have transformed a snowy landscape to a summer landscape. So in this project we will be covering to the basics to the advanced level. We will be first covering the basics of machine learning techniques, giving you an hands-on experience on the basic models like regression and classification models, then moving on to some advanced topics like neural networks, and finally jumping onto the advanced topics like the state-of-the-art models of GANs and diffusion models, which we will be using to achieve our final goal, which is the translation of images. Next slide, please. So moving on to the key features of projects. So we will be starting our projects with the basics of machine learning. We will be covering the standard basic algorithms like gradient descent, linear regression, logistic regression, and other classification models. After covering that, we will be moving to the deep learning and computer vision techniques. We will be first learning the feed-forward neural networks, then moving on to the convolutional neural networks, and yes, most importantly, we'll be having assignments so that you can have a hands-on experience on all these things. Remember that we will not be just applying these, we will be first covering the theory behind this, you will be understanding the concepts behind all these machine learning models, and then at the end, after learning the concepts, you will be applying those concepts in the assignments, where you will be doing classification tasks on the images. So, and then we will be moving to our main aim, which is the translation of images. May I please get to the previous slide? Okay, thank you. So then we will be moving to the main aim, which is the GANs and diffusion models. We'll be understanding the basics of GANs and diffusion models, and we'll be learning how to train and evaluate them. So this will equip the mentees with the basic skills that will be required to what is the main technique behind the translation of the images, and then we will be also making our mentees capable of applying these cycle GANs models, diffusion models to the every real time application. They may use this model for any kind of image that they want for translation. Maybe they can give an image of day, and this will be simply translating to an image of night, maybe. So moving to the next slide. So here are the logistics. This will be an only machine learning based project, and it will be of 8 weeks. This is a bit heavy project. We are expecting on an average 2 hours per day, which is around 10 to 12 hours per week. And we are expecting 18 to 20 mentees in our project. The prerequisites are Python programming basics, so that you will not be having much problem in the initial weeks. But no worries, we will be covering these also. We'll be providing resources for that. And yes, the most important thing is enthusiasm. You should be having a lot of passion, and you have to show a lot of interest in the project so that you will enjoy the learning process. So here are your mentors. I am Abhishek Khandelwal. I will be mentoring the project along with Prashad Hussain and Divijan, and these are our contact details. And I'm going to the next project.
Thanks. Now we'll be moving on to programming club projects.
Excuse me, hello.
Sorry.
Yeah, we are continuing with the project.
Hi, I am Anesh. So moving towards the next project, that is multivariate time series forecasting using deep learning. So in this project, what we will do, it is mainly concerned with the forecasting of various real-time trends like the energy consumption, like what amount of energy and what category of energy is being used in this scenario, and we will be learning some statistical models and deep learning models to forecast these trends. So next slide, please. So talking about the key features of our project, so we will begin with the statistical analysis, like we will do ranker causality test, principal component analysis, and some basic models like moving average model, linear regressive model, and its mathematics also, and some other statistical stuff like the dimensional reduction, correlation, and covariance. So next is univariate forecasting. So what it actually means, it is mainly concerned with one variable trend forecasting, and we will be using some statistical models like ARIMA and SARIMA for this. So moving towards multivariate forecasting. So here things become a little bit complex, like many variables come into scope which may not be interdependent. Say forecasting becomes a little bit difficult task. So what we will do, we will use the VARMA models like VARMA model to predict the multivariate forecasting trends. So the main feature of our project is the machine learning part. So what we will be doing here, we will be building the machine learning concept from the very basic fundamental level to a high level approach where we can apply sophisticated real models to predict the energy consumption trend. That is the main objective of our project. So next slide, please. So we are expecting a total of 15 mentees, and the workload will be, we are expecting 8 to 10 hours per week, and surely there is no prerequisite for our project, but basic Python knowledge is appreciated. Next slide, please. So the mentors of the project are me, Ayush Baghi, Madhavya, and Sashmi. Thanks. On to the next.
Hello guys, I guess I'm audible. So moving on to the last project offered by ICG, which is navigating consumer decision making in e-commerce. So in this project is basically a hybrid project, that is we have both data science and consulting elements. And first of all, I'll give you a brief overview of what the project is. So in this project, basically you'll be doing a comprehensive analysis of customer behavior, basically in the e-commerce sector. So you'll be merging consulting frameworks for the same as well as the data analysis part from the data science sector, and you will try and understand the structure and operations of online businesses, how the customers think, and how it impacts the success of a business. So towards the end of this project, you will navigate through this, and you yourself will do the analysis and come up with recommendations or valuable insights that you gain from both consulting as well as data analysis. Moving on to the next slide. So your key takeaways from this project. So by the end of 8 weeks, when you complete this project, you would have mastered the basic consulting frameworks. We'll start from basic market analysis, competitive analysis, and then we would move on to the advanced frameworks. And then we'll also have a deep dive into our main topic, that is customer behavior analysis, where you will analyze buying habits, retention metrics, and other factors that affect how the customer thinks. And here you will apply the basic strategies and models that we introduce to you. And then we'll move on to the sector of e-commerce, particular sector of e-commerce around which our project revolves. So here you will grasp the core fundamentals of this sector, as well as we will introduce basic business models that are in the play, as well as how it impacts, how the customer behavior impacts the sector, and how the success of businesses are driven by the same. Now we also have a data analysis part in our project. So in this, basically we will start from basic Python, then we'll move on to the basics of ML, regression, and all that. And then we'll move on, in addition to that, we'll also learn about AI explainability feature to analyze customer data. So it is not about just rote learning ML concepts. You guys will be applying it to derive insights. So it is basically merging your consulting knowledge as well as your ML prowess that you will gain through this project. Now moving on to the next slide. Yeah, the logistics. So the basic division of this project is, it will be a consult heavy project. So you can expect 60 to 70%, and the rest would be ML, data analysis, and AI explainability. The duration would be 8 weeks, and we are expecting 15 mentees, maximum of 20, so that we can cater to each one of you properly. And you can expect a workload of 10 to 12 hours per week, which would include our classes, or more specifically, it would be our interactive sessions, and then you would have assignments. We have curated a good set of assignments so that you have a very deep understanding of the concepts. And as for the prerequisites, as you all know, none except high enthu and sincerity. Because you are staying here back in summers, we are staying here, we want it to be productive for both of us. And a basic Python knowledge will be appreciated, but it is not necessary because we will be covering everything from the basics. Next. Yeah, so this is our team, Ishan, Kanish, Par, and myself, Shara. Our contact details have been given here. Feel free to contact us in case of like any doubt or anything. Moving on. Yeah, so that was the end of Summer Projects by ICG. We look forward to meeting you all during the summers. Stay in touch. Bye-bye.
Thanks, Shara. Now we'll be moving on to Programming Club. Programming Club कहाँ है?
Yes, so I'll be presenting from Algorina. So Algorina is a project about competitive programming. And next. Next slide. Am I audible?
Yeah, you're audible.
Can we move to the next slide, please? So first, what is competitive programming? So competitive programming is a mind sport where you are given some questions and you have to solve it in a fixed time frame, and then you are ranked. There are contests in which you are ranked according to how many problems you solve and how much time you take to solve these problems and how many wrong solutions have you made. So these problems are often related to infrastructure, algorithms, maths, and logic. Next. Next slide, please.
I think Han's audio. I will be switching the presentation slides. मेरा ऑडियो सॉल्व गया था. You can resume. नहीं, it's sorted now.
Okay. So yeah, next slide, please. Hello? Can you please go through this? Yeah. Okay. So as I said, competitive programming is. Competitive programming, we have contests and you have to solve problems. So these are some popular competitive programming sites which are Codeforces, CodeChef, Acrobatic, and LeetCode, and these hold contests regularly, like in the frequency of 2 or 3 times in a week. And next slide. So why should we do competitive programs? First, it's really fun. You get to solve problems that challenge you, and problems that will demand a lot from you, and problems that it's a journey where you will learn a lot of concepts. And if you are into solving puzzles and maths, you will really love it. And next slide. And also to understand the CP means. So we have a great means of culture in competitive programming, and you will love it. If you start doing competitive programming, you could also be a part of that culture. Next slide. So here is the outline here is a very basic outline of what you're learning. So we'll start with greedy algorithms, binary search, GAN programming, and we'll move to graphs, and then we'll also do advanced data structures like segment trees, binary index trees, and mostly these are all just these concepts that we'll learn. The most important thing is that we'll learn is the art of problem solving and how to tackle problems, and how to go about thinking of them. So the logistics of the project is as follows. The bare minimum that we will ask from you wouldn't be too hard project, so we have rated the difficulty as medium. But if you want to do well in CP, so you'll have to spend a lot of time, and it's a long journey. And so it definitely is we have tried to make the project slow-paced, and that it will be you'll be comfortable covering all the topics. So, but if you want to do more, and if you want to achieve a high rating in your CP goal, then of course it demands a lot of effort. The duration of the project will be around 8 weeks, and we expect to take around 30 mentees. The minimum workload, which we expect from you, is 20. That will be giving you contests every week, and will be giving you problem sets every week. So to solve them and to keep up with the classes, we expect you to give a minimum of 20 hours a week. It will ideally it should be more than that, but that's the minimum, and the mode will be offline. Next slide. So here are the prerequisites for this project. So you should first just be familiar with basic programming concepts like time complexity, binary search, recursion, and you should also be familiar with basic C++ knowledge like HDL and containers, vector pairs, etc. And some basic knowledge of probability and combinatorics will also help. These prerequisites will be tested in the form of recruitment tasks, which will be details of which will be conveyed later. We will be taking one written test, and we'll be taking also one contest. All those things will be told later. And next slide. So here are the mentors. It's Divyansh Garg, Jayan Jha, Prerna Agarwal, and Swayam Sid Pradhan. We have also given the contact numbers. You can contact any of us if you have any doubt related to project. Thank you.
So the next project that we have is Mastering Web 3.0. So Web 3 is like one of the most hotly debated tech topics. So you must, can we go to the next slide? So you must have heard of coins like Dogecoin, Bitcoin, Ethereum. These are like all based on Web 3. So Web 3 is like most people may call Web 3 as blockchains. So you must also be fed up with servers of Instagram, WhatsApp, and all these going down. So most of the internet applications along with these are based on Web 2. Web 2 means they're centralized. A single entity decides how the data is used, how it is stored, and where the data should be placed. So instead, Web 3 offers a very decentralized solution for it, and it allows the community to decide like where the information should be stored, how it should be used. Can we go to the next slide? So I'll give you a very good analogy for this. Like if Web 2 is dictatorship, then Web 3 is entirely democracy. So in this project, what all you'll be learning? So you'll be learning Web 3 from entire scratch. You'll learn how to write your own smart contracts. You'll also learn how to implement those smart contracts into dApps. Like you'll learn how the smart contracts that you write, you'll learn how to make those into dApps. So the final aim of this project would be replicating the Wordle game. So instead of the Wordle, the simple Wordle, we will make based on ITK Lego. That is the words which come will be of ITK Legos, and then each of the campus members would be able to like log in with their wallet and then attempt those words and solve the Wordle for that day. So that would be the final goal of this project. So this is a brief of what all you will be learning. So first we'll cover the entire theoretical concepts of Web3. That is, you'll learn the blockchain fundamentals, cryptographic principles, the entire ecosystem on how the Ethereum works. You'll also get a hands-on experience on writing your own smart contracts. Like you'll be able to replicate entire data structures, whatever you do on normal programming, that you'll be able to replicate on smart contracts using Solidity. You'll also learn the basics of front-end development like HTML, CSS, JS, React.js. And then the smart contracts that you write, you'll also integrate with the dApps that you make. So there would be a lot of errors. You will have to like put in your time and solve those errors. So these are the logistics of the project. So the difficulty is medium, like that entirely depends on you. Like if an error occurs and you are able to solve it quickly, yes, then it would be medium, or else it would like go on for a long time. We expect the duration to be around 8 weeks. We're expecting around 20 mentees. So the workload of this project would be around 15 to 20 hours. This includes the offline sessions we take, the assignments that we give you, the reading resources that you're provided. So these all, I think, if you do it properly, would take around 20 hours per week. and this project would run in offline mode. So what are the prerequisites that we are expecting from you? So first of all, the entire solidity in which we write our smart contracts is based on OOPS. Hence, we require that you should be familiar with OOPS in C++ or Java or any other language. And a basic knowledge of front-end would be like a plus because the apps are entirely based on front-end. These are the details of the mentors. Mayank Agarwal, that is me. We have Tamogna, Chayan and Kinchit. You can contact any of us on these details.
Okay, so the next project we have is NFS Goes Online. Next slide. Okay, so what will actually happen in the project? So this project will actually give you an idea about low-level programming and will actually help you dive into the fundamentals of systems and networking, how things actually work on the low level. Next slide. So why this project? So first of all, this project will actually give you a comprehensive understanding about how the underlying infrastructure of computer networks actually help. It will provide you a hands-on experience to apply the theoretical concept which we will be learning along the project. It will give you proficiency in systems and networking, which are actually in high demand in the job market, and they are actually very niche domains which are not mostly explored by people in college life. Next slide. So what will you develop in the project? First of all, one of our deliverables would be a small web server which would be completely written in Rust. We will be able to access different TCP/IP protocols with the help of that server. Next slide. The major deliverable of our project would be writing a complete distributed file system which will be written in C. This will actually help you get knowledge about how the file system actually works, how files are shared from one place to another inside your machine. So we will be following the well-known OS book, which is highly acclaimed for the file systems. We will be writing network wrappers using UDP, a functionality which is available to the end user. We will be writing a complete network file system, which would be similar to the Sun Microsystems network file system. Next slide. We will be learning the various difficulties in system programming and system designing. We will be also learning how memory leaks are handled and using tools such as Valgrid and GDB, which are actually a lifeline to the system developers. We will also deploy and run the system on various computers at the end of the project. Next slide. Okay, so we are actually looking for only very serious mentees for this project. As this project includes a little bit of theoretical knowledge, we have rated the difficulty as tough. The project will last for 8 weeks. We are looking to intake 15 mentees. The workload will be around 20 hours per week. This would be including the sessions, the assignments, which we will be giving out to the mentees. The project will obviously be running in offline mode. Next slide. What we expect you to know is some basic Rust, which is up to chapter 3 of the Rust book. Some Linux file basics, small basic bash commands, such as rm, cd, mkdir, etc. And C language up to ESC 112, which we all believe you must be knowing. Next slide. So the mentors of the project are going to be me, Hardik, Ashish, Ritvik, and Shivansh. We have listed out the contact numbers in case you have any doubts. Feel free to ask us. Thank you.
So the next project. So the next project is IITK mail client. So in this project, we aim to develop a mail client for the campus, and we envision that this will be used by the campus janta, students, faculties, as well as staff. And also, when I say a mail client, I mean that we will be developing a mobile app for the campus janta, for similar to
Gmail or Edison Mail that you have been using right now. So the question after this is why do we need a mail client? So the simple answer to it is that we can't simply trust the mail apps that we currently are using. For example, till last year we were using MyMail and that got crashed like last year. So that's why we need our own mail client, and above all, customization is the crucial part of it. Majorly, we will be customizing it for IIT Kanpur, and it will be very specific to IIT Kanpur. And also, apart from its usage, it's a cool thing. So we'll be doing that. That pretty much is a good motivation, in my opinion. So yeah. Next, what we will be learning in this project. So first of all, you'll be building a mobile app. So you'll surely learn Flutter, and that we are making it in Flutter. We will be learning for Flutter and that like basics of Flutter till some advanced level. And after Flutter and Dart, since we are making an email app, so we'll have to learn email protocols, some networking things. Namely, we will be learning SMTP, IMAP, JMAP, and POP3 email protocols. And also, we'll be adding features to our app mail client. And therefore, you'll be working on a product that will be used in real life. So it will be a professional product. So I think you'll learn. It will be a wholesome experience for you, because there's a very big difference in developing an app and putting that app in production. So you'll be learning a lot through that, and also we'll be deploying it and we'll be testing it. So it will be a good experience. And lastly, you'll also be given credits for that on the app. And yeah, now this cleaning part. So we don't expect everyone to have knowledge of Flutter. The prereqs are simple. We need to have some basic development knowledge and some experience in that. And the selection task will be front-end and back-end tasks revolving around the mail client in any language or framework you know. Also, if you know Flutter, it would be a plus. So coming to the logistics, I would like to mention here that this project is very intensive project, and this is a very serious project. Like if you are applying, you must have motivation to complete it, because we take it very seriously this time, and we'll be completing it. We have a very high bar for that. So this will be a tough project, and its duration will be 8 weeks, and we'll be taking only 12 mentees for this, and you'll have to devote 20 hours per week for this project, for the whole duration of the project. And of course, it will be in offline mode. Yeah. Also, these are the mentors: Brandon Merchant, that is me, and Yash Chauhan. Feel free to ask me doubts.
Feel free to ask any doubts.
Hello everyone. So the next project is on version control system. So this is just a meme on that you simply don't understand it. This is not about the Git software as being too hard, but this is actually about the fact that if you really want to understand how Git is working under the hood, so that is not easy. And this project is about it, understanding the fundamentals of version control system, and we'll go one step ahead. We'll try to build our own. Okay, next slide. So what we will be learning in this project, so of course, what are version control system, and Git is probably the most popular version control system. So that will be our reference throughout the project, and we will be making our own version control system like Git, and it will mirror Git in the sense that we will first understand the working of Git and then try to implement it on our own. And along with it, of course, in the way you will learn some cryptography and file compression in this project. Okay. Next slide. So So what exactly are we building? It's written here that we are building a version control system like Git, which is compatible with Git. So compatible with Git means here that every feature that Git has to offer, not every, but every major feature, which includes commit, merge, and all other features. If you have not heard of them, you will probably, we'll talk about Git first in our project. So like all the major features of Git, it would be compatible in the sense that our version control system, which we are building, will also have all those features. And apart from it, we will also build a web server. So here, a distributed version control system. So GitHub is basically a web server built on top of the version control system, and it is for collaboration. So that would be another thing that we will build at the end. Next slide. So just to give you idea of how this project will flow, like you don't need to read the code right here. You can read it later if you get the slides. But to tell you how we'll go with this project, first we will try to explore the Git commands on like what happens when you execute a particular Git command. We'll explore it, we'll see what changes happen in the Git repository, and then we'll learn about it, and then we'll implement it. So here we just created a dummy project, and we did if you don't understand it, it's okay. You can just read later about it, but here we just created a project, initiated a Git repo, and we saw what happened. Then we did a commit. Okay, so next slide. And after commit, we saw some changes in the Git repository. So this is how our project will flow. We'll analyze every command, see what changes it is doing to our repository, and then implement it from scratch. And in that process, we'll get to learn algorithms. There are algorithms for merging in Git, and then for conflict resolutions, there are algorithms. And then data compression is very highly used in the Git software. So this is all the things we will learn along the way while we are building our own version control system. Next slide. So the logistics of this project. So see, this project is a code intensive project. Okay, we'll not exactly be doing we will coding in all the sessions. We will be reading about algorithms and how the version control systems are working, and then we will plan how we'll code it. But you will have a lot of code work apart from the session. So if you are willing to do all those code work, you should then only look to this project, because it is going to be code intensive. That's why the difficulty is tough. The duration is 7 weeks, and we are looking for around 10 mentees. Workload is around 20 hours. Now this, the 20 hour includes the sessions and the code work which I'm talking about, plus maybe some reading material. Okay. Next slide. So please requisite basic data structures. So by basic data structures, I mean like you have read in SE112 till linked list, and if you have some basic knowledge of tree, that will also help you, and will provide with the playwright. And so basics of Golang, like Go by example here is a good resource to learn some basics of Golang, because we will build our version control system in Golang. So that's why you should know at least the basic syntax and like how to define functions and everything in Golang to get started. And then basic shell commands, because we'll of course be exploring the Git repository, and we'll frequently work with the command line. So again, it is expected that you know basics of it. Okay. Next slide. Okay, so here are the 4 mentors: Aman, Sameer, Shreya, and Yash. Yash, it's me. Okay, so you can contact any of us to know more about the project. Thank you.
Hello everyone. So the next project that we have is Illusion Craft, a dive into artificial creativity. Next slide. So the project will be basically on GANs, generative adversarial networks. We'll be understanding how GANs work, their variations, and obviously we'll be exploring their applications in the real world. The project will be mainly implementation based, and by the end of the project we aim to develop 2 models. Next slide please. So the first will be a text-to-image generation model, which will be capable of generating images on the basis of a prompt that any person might give. For example, a person might give an octopus reading a newspaper and it will generate an image similar to this. Next slide. The second model that we aim to develop is an age transformation model, which will be capable of aging and de-aging images of individuals. So that will be the second deliverable, major deliverable of our project. Next slide. So the logistics, it will be a heavy project in the sense that it will require nearly 25 hours of commitment from each mentee. The duration will obviously be 8 weeks, and we intend to intake 12 mentees for this project. The project is going to be tough, and we encourage you to apply only if you are willing to put in that hard work. The project will be in the offline mode. Next slide. So what are the prerequisites? We expect you to know basic linear algebra probability, basic of Python programming, some fundamentals of machine learning, namely linear regression and gradient descent, and a bit of OOPS concepts are recommended, although they are not compulsory. Next slide, please. So the mentors are me, that's Abhishek, Rudradeep, Raghu and Abhijit. These are our numbers, and you can DM any of us for any further queries that you might have. Thank you.
So the next project is the Capture the Flag. Next slide. So what are the CTFs? As you know more about the cybersecurity, the Capture the Flags are the gamified competitions which basically targets the cybersecurity and ethical hacking domain. It's based on many exploitation and competition based on the teams which you have to exploit some softwares and programs. It is mainly team-based competitions, and which you have to find the secret flags which are next slide. CTFs are super fun. In CTFs you learn many new things while participating in the CTFs. Sometimes you don't know some language, you will be learning in the CTF while participating in the CTF. You have to more enthused on learning new things. You will develop a hacker mindset. You will many times you write programs, you will learn how to find your own vulnerability in your own programs, how something works. If you know how something works, you will find more easily how it will break. In CTFs prize money, there are prize money, swags, conference tickets, and many more. But most importantly, you will be learning about many domains. Next slide. So what we will be doing in this project? We will be participating in multiple CTFs and gaining learnings on multiple domains, which is binary exploitation, reverse engineering, cryptography, web exploitation, steganography, and miscellaneous. Its actually domain is very big. It can cover ML, exploits on ML's hardware and many more stuff. Next slide. So what will happen in this project? Basically, we are participating on the some list of CTFs, and we will maintaining the writers and solutions of the CTFs we have solved. And there will be a team-based evaluation between the mentees. And we will be organizing a doubt and lecture sessions based on the weak topics of mentees. Generally, they are reverse engineering and binary exploitation because they are not that much explored. And we will be also discussing some unsolved problems and flags, which are we will also provide some resources on CTF advanced stuff. And if you solve that, we will be discussing the unsolved problems also. Next slide. So logistic difficulty will be tough because in this project you will be learning many things by new many things are new actually for you, and and duration will be 8 weeks. Number of mentees are 15. Workload will be 20 hours, which will be including all the lectures, assignments, and CTF. And mode will be flexible, online and offline both. Next slide. And the prerequisites will be you have Linux fundamentals, C language, you have like basic like language understanding up to the ESC 112. Some web dev knowledge will be needed, and you have go through all the basic domains. Like every domain, you have basic knowledge of everything, and some Python language is optional. Like next slide. Here are the mentors. Ritik Goel, it's me, and there will Aman Singh will also. Thank you.
With that, we've reached the end of our projects. One final note to all students who are looking to become mentees under the programming club. Know that we'll be spending our summers here as well, and since you are spending your summers here as well, we'll be making sure that your time does not go to waste, and it is a sincere request that you do that, like you extend the same courtesy to us, and all we expect from you apart from the prereqs in the projects, I know you're sick of hearing this, we don't really expect enthusiasm with respect to, like zeal of learning things. We do expect that, but then additionally we also expect a lot of sincerity from your side, wherein you put your hand up and get the tasks done that are assigned to you. That we would like to end our proposal.
Thanks, Divyansh. Now we'll move on to Robotics Club.
Just a minute. I'll start the screen sharing in a minute. Hello everyone. We are the Robotics Club, and this year we have come up with 4 projects. Note that 3 of them are going to be 3 of them are devoted to building the rover, which has 3 elements: the arm, the navigation, and the controls. And another project is based on a self-balancing robot. These projects are aimed for national level competitions, the RoboFest that is held in Gujarat, and IROC, which is held in Bangalore. IROC is conducted by ISRO. It is a rover challenge, and we hope to see you take the lead in this and help us represent our institute in this. Also note that all the projects are conducted in offline mode. We expect a lot of sincerity and enthusiasm for this, so hope to see you in good numbers. Let's get handing it over to Yuval.
Okay, so let's talk about the first project. I am Yuval, who will be mentoring this project. So this is Gyrobot, a self-balancing robot. Have you ever wondered what keeps self-driving cars on road, even when roads are not straight, or keep the drones horizontal, achieving sufficient angular velocity in all the rotors? Please change the slides. This same principle is used to maintain pH of substances in pH regulator machines, as well as control temperatures in microwave ovens. Control systems. In simple terms, control systems are used to maintain process variables at a desired set point using control loops. Data is received from sensors that is used to drive an actuator in real time. So this bot, Gyrobot, is a robot that can balance itself irrespective of the forces that act on it. It is also remotely controlled while staying upright on 2 wheels. Please change the slides. It will use data from IMU, an inertial measurement unit. It is a sensor that is a gyroscopic sensor. Basically, it is used to detect the orientation of the bot, and it will use PID, that is proportional, integral, and derivative control system, to actuate the motor drivers. Let us see the demonstration of the robot that we are going to build. Cool. So this bot will be remote controlled as well. These are the skills and tech that we'll be learning from this project. Control theory, that is building a control system that will drive a robot using PID controls. Working with Arduino, we'll be working extensively using microcontrollers, and we'll also learn how to use it with IMU sensors and motor drivers. Mechanical design, well, there are various challenges that we'll face working with hardware, so we'll learn how to overcome them. Also, there's an element of CAD designing. So we learn how to design CAD models on Fusion 360 and 3D print them using Robotics Club's own 3D printer. And then comes PCB designing. We'll also learn how to design PCB using software like Altium for this project. We do expect a commitment of around 12 to 15 hours a week for 8 weeks during our summer breaks. We do not expect any prior technical knowledge for these projects, but your eagerness to learn. We'll share some resources. Going through them will be enough to work on these projects. This project will be mentored by me, Yuval, Sanskar Yaduka, and Rishi Bagel. Feel free to reach out any of us for any doubts. Overing to Ayush for second project.
So hello everyone, this is Ayush Jaswal, Robotics coordinator. I will be taking the second project. So our second project is Space Station Controls and Communication. Next slide. So a space station is a spacecraft capable of supporting human crews in orbit, which can control and monitor data from the rover. So we'll be working on its 2 parts, like in communications, we'll be building a radio frequency system which can control the movement of rover and transfer live video data back from rover up to 3 kilometers. Then there will be control part. In control, we'll be learning feedback loops and using it to control the exact speed and the motion of the rover. Next slide. So what we'll be learning in this project. So we'll start with Arduino. We'll be learning how to use Arduino and use it to data from different sensors like accelerometer and encoders. Then we'll be moving on to control theory. We'll be using feedback loops and PID control for the motion of the rover. Then we learn how to use Zigbee, which is a communication module. It can transfer data to 3 kilometers, and we learn how to establish a two-way communication between the rover and the station. Then finally we will be learning robot operating system. We will learn how to use it in respect to rover. Next. So it will require time commitment of 15 hours a week, and it will be done only in offline mode. We don't expect anything, but we will provide some documents related to it, which we can do. Next. So we will be having 4 mentors in this: Ayush, Espas, and Keith, Varun, and Dash. So next. So Sheikh will be taking on.
So, hey everyone, myself Abhishek Srivastava, coordinator of Robotics Club, and we have come up with another project related to autonomous navigation of Mars rover. Next slide. So, this whole project is about designing and simulating the system of navigation of our Mars rover, on which we are currently working upon, and we are going to take part in IROC and Guj Post. And in this project, we are also gonna deal with obstacle detection and classification along with the path planning of the rover to a specific location. Next slide. So, what are the learning values of this project? First of all, you guys are gonna learn about ROS, which is basically the robot operating system. The whole programming will be done in it only, and also along with that, you'll be learning and implementing the fundamentals and principles of computer vision, machine learning and deep learning for tasks related to object detection, clustering, segmentation, and obstacle avoidance. Along with that, coming up to the last part of the project, we will be also dealing with the path planning of the rover and localization of the rover also, so that the rover can conveniently plan its path even if any obstacle come in its path. Next slide. Along with me, there are two more mentors, Garima and Nikhil Gupta, mentoring this project. And here is a demonstration video of the stuff which I told you guys just a second ago. So as you all can see, the exact task which I told you guys is being performed in the simulation by the rover. It is dodging the rocks and planning its path autonomously according to its purpose. Next slide. So we are expecting a time commitment of roughly 14 to 15 hours a week from your side, and the mode will be purely offline. The prereqs are none other than basic programming skills and shell commands. And for the programming skills, we are hoping that you guys must have learned something from your ESC 111 and 112 course. And for the shell command, we will be providing you some basic resources. And along with that, we are also hoping that you guys follow the resources which we will be sending you from time to time sincerely. So this is all from our side, and hope to see you in summers. Thank you. And handing over to Manvi now.
Hello everyone, this is Manvi Vengani, and the project that I'm offering is the robotic arm. This arm is also going to be a part of the Mars rover. In general, the robotic arm has a lot of industrial application in warehouses and industry manufacturing. And there's a lot of physics and science that goes behind it. The project is more or less going to work around going in stepwise format. Firstly, in the controls of motors using microcontrollers and encoders. Then we will jump to the core robotics, which is inverse kinematics, and we will try and implement this on robotic operating system. The net result that we expect from this project is that the arm will be able to autonomously pick and place a randomly placed object. Here's a short demo. The learning values that we can expect out of this project is firstly robot operating system, which is essential to almost all robots. Herein, we will firstly be teaching you the fundamentals and then you will be doing assignments. After that, for the arm, we will be using a Raspberry Pi with Robotics, which will be used to control the arm. Then the basic theory and implementation of inverse kinematics, which is basically the mathematics behind the angles and link lengths of the arm. Thirdly, to control the arm motors, we will be using proportional, integral, and derivative control using encoders and IMUs. And to facilitate the entire learning process, you will be gaining some practice in object-oriented programming in Python, since our project is very software-oriented. Lastly, you can expect a time commitment of a minimum 18 hours per week, and it will be conducted in offline mode, so we expect you to come to the club and work with us. The number of mentees is going to be around 10. The other mentors along with me are Divyam Agarwal and Vignesh Patidar. This concludes all the projects of RoboClub. We expect a fully functional rover at the end of the summer, so it'll be fun watching this and contributing to this. And if at all interested, we can always take part in competitions going forward and stay connected with RoboClub in the long term. For any details, contact the coordinators as the contact details are given. Thank you.
Moving on to BCS, I guess if you can take portion now.
Yeah. Is my screen visible?
Yeah.
I would require listening to turn on your cameras.
Hey everyone, this is BCS IIT Kanpur and we are presenting our summer projects for the year 2024. And we will have a combination of projects of AI, ML and Neuroscience, as well as a combination of both of those during the summer. And starting off, we will be having illuminating languages. This is Utpal's project and he'll be presenting now. Unmute.
Yeah. So the first project is illuminating languages. It is an introduction project to LLM. So as there has been a recent surge in generative AI and LLM, so I guess this is the right time to just dive in. So let us see. So basically what our project offers is, we'll be starting from the basic of NLP and building up right to the advanced concepts of NLP, and then we'll be seeing what all things can be done with the LLMs and how we can make an LLM answer upon the very specific queries that we have, or like for example ChatGPT has a knowledge cutoff of January 2022. Now if we want to augment it with the information after that, so how can we do that? So the prerequisite
prerequisites and logistics of the project. Yeah, we would require basic Python knowledge, basic programming skills, like implementing a for loop, while loop, NumPy, and basic machine learning. Like you should know that what is an activation function, how to implement gradient descent, and yes, of course, N2. So, based on these three prerequisites, there will be a recruitment test for the project, and based on that recruitment test, we'll select 12 to 15 mentees, and your weekly commitment will be 20 to 25 hours per week. Now, let us look at the timeline for the project. Okay, so first would be an intro to NLP of all the basic things that like semantic search and querying and parsing it, embeddings, all the jargon of the NLP. So, in the next 2 weeks, we'll be collecting data all over the internet and all over we can get about IITK, and then we'll be structuring that data to make a data set. After that, you'll learn about some basic about LLM frameworks, what are the random architectures that you can use. Next, on the 5th week onwards, you'll learn about QLoRa and other fine-tuning methods that will be used we have just made. So that was it, and if you have any doubts or anything, you can reach out to the mentors. These are their Discord IDs. Thank you very much. Now let us move on to the next project.
Aditya hasn't joined in yet, so let's move on to my project instead.
Okay.
Okay, so this project is something that revolves around the intersection of AI/ML and neuroscience. We will be detecting drowsiness in, say, drivers or any sort of person using EEG datasets. So the mentors for this project is me, Zehan, and Viral. They are busy today, so they haven't joined in. Go to the next slide, please. So, EEG, you guys will think it'll be sort of complex and like mind-boggling and all of that, but don't worry, aisa kuch nahi hoga. Next, please. So basically, in this project, you will learn how to understand EEG signals as well as utilize deep CNN models. CNN is convolutional neural networks. वो सब हम लोग सिखा देंगे. That is not an issue. So don't be afraid of these short forms which you might not understand now, because during the entirety of the summer project, you will learn what these are and you will understand what these are through by being with us. So this project is basically an implementation of an IEEE paper. So it tells us how you can use and build a new kind of CNN model in order to detect drowsiness in drivers. So go to the next slide, please. So this is going to be our timeline. In week 1, we will mostly learn about CNNs from the get-go, from the very beginning, and we'll also do a small project on CNNs, which will help you understand what the basics and the math behind CNN is. Then we will move on to EEG datasets and what EEG is primarily. Because for a lot of us, we don't really know what EEG is. That's why we are going to start again from the very basics to build it up so that you all can understand what it is. Moving on, we'll also learn how to pre-process and understand EEG data. You will not understand the lines and squiggles of EEG that easily, right? So we will learn how to understand those and basically read your own brain. In week 5, 6, and 7, we will start doing our main project on drowsiness detection, and we will build our model, our CNN model from scratch, and we will write our own code. So it's going to be from the very beginning. You're going to make the layers. So it's going to be very interesting. I hope you guys join in. Next slide, please. So at the end of it, the main thing is that you will learn how to successfully implement a paper, something that is very important in this day and age. Papers are released every day, but to understand and how to implement it is something completely different. We will also learn the concepts and implementation of CNNs and deep learning CNN models. We will also learn how to pre-process and understand EEG data, which is basically understanding how your brain works. And you will finally build a fully functional CNN model that can help you detect drowsiness. Go to the next slide, please. So prerequisites is nothing but enthu, interest, and slight bit knowledge of ML and Python. There'll be recruitment tests based on all of this. And the time commitment required for this project will be 12 to 15 hours per week. Next, please. Thank you, and if you have any doubts, you can contact us. Our Discord IDs are given here. Just a minute. Okay, so I'll help present this. The Minds Mirror. This is basically a project that is being offered by Devapita and Srini and Pujal. Go to the next slide, please.
I think there are people who need to be let into the meeting.
Yeah, they've been asking us. Hardik, if you
there is nobody waiting on this issue. So, is there anybody in the meeting room?
No, अभी तो कोई नहीं है.
Okay, if that's the issue, could anybody else take it up till then?
I guess everybody, all the mentors are saying that we are waiting for us to be let in.
And then, okay, yeah.
Yeah, they are coming.
Yeah, so as Manasvi has already introduced, our project's name is Minds Mirror. In this project, we aim to use EEG data to predict what that person was seeing. So we work on a data set which has the EEG data of a person while he's looking at a picture, and then try to predict at what he's looking from the EEG data. So through this project, we will have a brief idea about how to deal with EEG and so the stuff you learn in this project is, apart from understanding RNNs, CNNs, and LSTMs, we'll learn about these acronyms in detail through the project. And we learn how to understand EEG data and this squiggly lines, and obviously about the biological aspect of it as well. And the most important thing is mastering the art of reading research papers and figuring out what parts are important and deciphering the jargon. In the first week, we'll briefly learn about the function of the human brain, the focus, visual cortex, and how it plays a role in object recognition, and some basic Python libraries. In the second week, we'll learn about the deep learning framework like TensorFlow and PyTorch. And in the third week, we'll proceed to the basic model of regression and classification. This is the basic of machine learning. In the fourth week and fifth week, we'll learn about CNNs and neural networks. And in the sixth week, we'll continue with recurrent neural networks. And in the seventh and eighth week, we will have we'll completely implement the final project. So the prerequisites are obviously N2 and a basic knowledge of Python, and we will learn from the basics of ML, so that won't be a problem if you're not very familiar with machine learning. The time commitment is 12 to 4 hours a week. And for further details, you can or doubts, you can contact us at our Discord ID. Thank you.
Hi everyone, I'm Shrishti, and along with 3 other mentors, Devansh, Deham and Aditya, I'll be bringing the project Sound Refine. So here's a little situation for all of us. Let's say the best detective of Brooklyn Nine-Nine, Jake Peralta, comes up to you asking for your help. So Jake basically has an audio recording of a very dangerous mafia who is planning a heist. The voices are faint and there's definitely a lot of background noises. Now Jake wants us to enhance the sound, and we definitely are very excited to assist him. But many of us might not know how to help Jake. So in this project, we'll be learning how to help Jake in this way. Moving to the next video. There were objectives also. Okay, never mind. So basically the objectives of this project will be, number 1, we'll be making a model which will take any raw audio and remove the unwanted noise and enhance the speech that is present in that audio. Number 2 will be, we'll transcribe the clean speech to finally obtain a transcript. So you might be thinking, why shall we make this in real life? Helping Jake was an idealistic situation, but in reality also we have a lot of use of such kind of model. So the first is, let's say we are present in a very, very boring lecture and you definitely doze off. So wouldn't it be wonderful if you just recorded the lecture, and from that recording you extract the voice of the professor and then transcribe that into text. So instead of listening to the professor's entire lecture, you just have to read the lecture. So that would save a lot of your time and efforts. So that is one thing. The other is, let's say one day you're feeling very nostalgic and you decide that you want to hear some of your old recordings when you were 5-year-old. Let's say you were singing some song or talking or whatever, and you want to hear that. You want to hear your voice. But definitely the audio quality of that time when you were 5 years old would be very bad in comparison to what we have now. So, and there might be some background noises of washing machine, etc. We want to remove that, and we just want to focus on the songs that you were singing, that is the part of the audio which has your voice. So again, we'll use this model to enhance the speech quality there. Since the number of mentees we are taking is quite less, we will be taking 12 to 15 mentees. So definitely there will be a recruitment test. The recruitment test for now will be 45 minutes long. So we'll be asking basics of NumPy, Panda, Python, and also very basics of ML, linear regression and perceptrons. Not much of that, but you should all have a little bit of idea about that. No, we won't be asking very much detailed questions about that. And yes, throughout, the previous page here. And throughout this project, we'll have 2 sessions per week, ideally. It might vary according to the needs of the mentees. We'll have 2 sessions. The first will be for theory and maths comprehension entirely. We'll be teaching you about the maths behind that and definitely the theory. And the other one will be for doubt clearing and the assignments that that we'll give you on weekly basis. All the doubts regarding that or the issues you come up with will be taken in that session. So here is the timeline. Basics of in the first week there will be basics of Python and ML, not the basics that we already asked in the recruitment test, but a little advanced version of that. Basically the things that we actually use in the project. Then week second will be intro to CNN and ANNs. Week third, understanding transformer architectures. Week four, audio processing fundamentals. And after week four, we'll basically have to create a model using CNN. Now this model will be image deblurring or image denoising. So this will basically in this project you'll learn the application of CNNs. Now from now onwards there will be audio processing libraries in week 5. From week 6 onwards we'll basically start working on the main project, the main aim, the model that we have been studying for all these weeks. Week 7 will be audio transcription model, and then week 8 fine tuning and testing. Definitely there will be a lot of buffer days between these so that you can, if you left somewhere or if there's any sort of backlog, you can cover that up. Okay, thank you everyone, and do join us.
So, hello Y23, the next project from Brain and Cognitive Society is the Stratolaunch, and the mentor for this project will be me and Sagar Arora. Next page. So before describing what the project is really about, let's give a thought about to how these text-to-image models such as DALL-E produces such realistic image just by using some text input, or how these e-commerce platform can visualize your image with desired trace inputs through descriptive text. Next. So the answer is through GANs. GANs to makes this thing possible. So the main aim of this project to help to make you guys understand the working of GAN and to implement the 5 research paper, where we'll be using the text inputs as shown as here to make the desired changes in the input image, such as for example, turn this black jacket to red, and to do more. Next page. And the desired output that is we are hoping to get from the paper is, you can see here, this is from the paper that we are hoping to get, and you can see we here have used the text input such as long sleeve, shine shirt, and our model is taking this input as image and giving the required output image having the text input in mind. Next. So the least thing that we expect from you is basic Python, of course, and some basic machine learning. Even if you are able to do linear regression, logistic regression, or you know how this activation function works, then you are good to be in this part of project. And how we will be taking the mentees, so there will be a recruitment test based on the prereqs above, and the number of mentees that will be taking is roughly around 15, and time commitment is a little bit higher, 20 to 28 hours per week, because this is a little bit of a lengthy project. Next. So if you have any doubt, you can timeline.
Timeline, you will have to tell it.
Timeline. So if you have, we will be sharing timeline with the PPTs after the Google Meet. So if you have any doubts regarding this project, so you can reach us, the mentors, on Discord. The Discord IDs are mentioned.
Okay, so that was it from BCS. So these are all of the projects that we are offering, and we hope to see you in great numbers. That will be very good. Thank you.
Am I audible?
Yeah, you're audible.
Okay. Ved, will you share the PPT?
Okay, I'm sharing.
Okay. We are from Science Coffee House. We are a group of science enthusiasts really interested in what different parts of sciences and the science behind various technologies. So if you share the same interests as us, we recommend you to take up these projects. We are offering 2 projects for this summer. The first project is quantum information theory. Mentors are going to be me and Ash. So yeah, next slide. So this meme you might have seen until now. Reading quantum physics is slightly hectic, but don't worry, you are not going to end up like this after this project. Next. So the project overview, this project covers the basics of quantum information theory. As you have known, quantum computation and various applications in quantum cryptography are being developed recently. So the major part behind these technologies is quantum information theory. So this project is going to cover the quantum information theory, basics of quantum information theory. And this project includes lectures and resources will be provided with you guys so that you can get through what is taught in the lectures. Next slide. So this is the rough timeline which we have proposed for the project. In week 1, we would be obviously covering introduction and basics of quantum mechanics to get you a solid framework in the basics of quantum mechanics so that we can continue with the project. In the week 2, we have the mathematical framework where we will be going through the linear algebra, which would be useful for the project. And from week 3 on, we are going to go through the basics of quantum information theory and various parts of it, like noiseless quantum information theory and noisy quantum information theory. And midterm evaluation will get to week 4. Next slide. So overall for the project, we would have 2 to 3 assignments given, and at the end of the project, we would also be exploring quantum optics along with quantum information theory, which also has groundbreaking applications in various technologies. So prerequisites, basics of linear algebra is quite helpful. But if you have seen week 2 of the timeline, we are already covering the basics of linear algebra. So it is not a compulsory, but basics of linear algebra would be quite helpful. And obviously, Enthus is needed. Time commitment, mentees should be willing to dedicate 7 to 8 hours per week. And this is variable. But the worst case, you should be willing to give 7 to 8 hours per week to this project. And expected number of mentees is 7 to 8, and mentees can be from both Y22 and Y23 batches. So this project is image processing. Where will take this?
So SCH is, am I audible?
Yes.
SCH is offering image processing projects. So the mentors will be me and SSV. So the basically timeline of this project is in the week 1 we are covering the basics of the Python and the OpenCV, NumPy and Matplotlib. In week 2 we are moving forward to the image histograms, and this comprises 2 parts. So this is, and week 3 will be intro to the downsampling and the quantization. And basically it is more to be in the mathematical backgrounds of what mathematics is behind these processes, and somewhat coding also. And in week 4, we are moving for the image transformations and the mathematics, obviously behind it, segmentation techniques. And in the week 5, we are moving forward to the edge detections and the corner detections methods, and also what process and the GPU processes and the mathematics behind how GPU processes. And in the week 6, we are moving forward to the techniques of the filterings of the image processing algos. And in a week 7, and in week 7 we are doing 2 parts, we do coding and also the mathematics behind all the various filters in image processing. And in week 8 we are doing the image template matchings, if there is many data sets, we are used to find two similar data sets like that. So the time commitment will be 7 to 8 hours per week, and expected number of mentees will be 7 to 8. And deliverables will be we will providing assignments and the documentation and YouTube playlist. Feedback is only N2, and these are the contact details of us, and follow our Descon. Thank you.
So these are the 2 projects offered from our side, from SCH. If you are a type of person is interested to know science behind various technologies, you have to use the technologies, and also if you are interested in knowing the science behind technologies, we strongly recommend you to take our projects, and we would be going through the maths and science behind them. Thank you. The presentation is complete. You are not audible actually, Hardik.
We are not audible.
ऑडिबल नहीं है अभी भी.
Am I audible now?
Fine.
Yeah, so thank you everybody for sticking together till the end. I hope to see majority of you guys in the summer projects, and special thanks to all the coordinators, leaders, and Sparsh for actually facilitating the entire streaming. I guess we can end now. If you guys have any queries or any doubts, you can ask your respective coordinators and leaders and the mentors, or you can ask doubts on the Discord channel. I guess Sparsh, we can end the stream.
Yeah, the stream is ended.